with the schools. Okay. Vivek, yeah. And that's the Srinivas and Mehta.
French pose, beautiful camel
Yeah,
pose.
I think you got a new chair or I guess from Armana Shamsi.
All of these things.
Practice.
How about you?
So it is right back here.
Yeah.
Yeah.
Okay. He will be here based on your really nice to see you as well.
The mics are off right now.
Can you track how many?
There are names.
Some of them. The other part of it. Or just doing it. When you engage. Yeah, because for whole PhD program, you cannot even find that many people. These are all. Oh, right. Just the number. For you. Okay, so good afternoon, everyone. It's my pleasure to welcome you to the annual tradition from School of Computing, carried over from the Department of Computer Science. This is every fall event where we have a research day and try and bring some interesting speakers and panelists on some cross-cutting topics, as well as involve our own graduate students through posters and so on. I remember when I applied for this job, I had seen pictures from last year's research day, and actually my very long time associate or someone I have known from my own research community, Srinivas Aluru, I saw his picture presenting last year. But we have another extremely distinguished speaker this year from Georgia Tech. We are also very fortunate this year to be represented by our leadership. So I have with me Dean Anna Stanport, Dean of the College of Art and Science, which is one of the two colleges we are located in. In about 8 minutes, I am told that Dean Don Leo will also be here. And we are also represented by Office of Vice President of Research with Dr. Hooks, who is one of the Associate Vice Presidents for Research. So I'd like to welcome Dr. Stanport to give a few introductory remarks. And as we proceed, and then in about 12 minutes from now, we will have Dr. Isa's presentation. Dean Stanport.
Well, it is so great to be here with you today. And thank you, Dr. Agrawal, for the kind invitation. I am very excited to represent the Franklin College of Arts and Sciences and to get a chance to begin to get to know you. This is just really tremendous. It is indeed a wonderful occasion for the University of Georgia, the Franklin College of Arts and Sciences, and the College of Engineering. to recognize with this annual research symposium the remarkable new interdisciplinary School of Computing. This is a jointly appointed school with broad horizons and a bright future. I have come to know, over just the past number of months that I've been on campus, the ways in which we embrace the distinctiveness of this School of Computing, because we embrace the bold and the new and the ambitious. We also embrace in the Franklin College of Arts and Sciences, in the school and in the College of Engineering, the reality that computing at UGA is different. A prominent computing school in a liberal arts and sciences environment that is new, and that in a school and a school in which you are challenging conventions about what collaborative research and innovative teaching can be. As the interface of leading edge programs in data science, AI, systems engineering, computing, the School of Computing is attracting the kinds of faculty and graduate students who want to be engaged in a new kind of computing, one that reaches beyond traditional disciplines by complement a computing that reaches across our world and connects every sector and every field of endeavor. And of course, these new big opportunities come with immense responsibility to think ethically about how we apply the powers of computing to change the lives, or to change lives for the better and improve our world. This is where our difference, the distinctive nature of computing at UGA, will make a difference. We bring together the best thinkers in AI, in ethics, critical thinking, historical context, communication, and cross-cultural understanding with experts in data science, computing, and AI, and cybersecurity. And this is the ways in which we can think big about the future, including the ways in which your work impacts the world positively, well beyond the colleges and the campus boundaries. Leading industries, as well as major government initiatives around the world, are powered by teams pushing machine learning, large language models, and many more innovations to their limits to meet our most complex challenges. I know you are energized to be in this work, and I salute your dedication and dexterity in such a quickly changing field. Being a part of these transformations, leading it in directions that prioritize the sustainable diversity of people and planet, will define excellence at this and many other institutions going forward. I'm really excited about your work, the promise of research in the School of Computing, and the many ways it strengthens our college and university. Thank you so very much, and I wish you a wonderful afternoon. And if for a moment I'll digress from the prepared remarks, Dr. Agrawal, if you'll permit me, it's really fascinating to see the great work by students reflected in the posters just outside the venue here, and to begin to get a sense of the range and breadth and depth of intellectual and creative inquiry that's really going on in your school. So thank you, students, graduate students, and faculty for taking the time to put these posters together, and for your interest in sharing your knowledge and contributions with a broader audience. I wish you a great afternoon. Thank you.
Next, we'd like to invite Dr. Hooks, who is Associate Vice President for Research at the university and also a researcher in pharmaceutical and biomedical sciences.
So I just want to add a few brief comments of welcome and encouragement and congratulations on a great day. It's really wonderful to see such a great crowd here today. And on behalf of the Office of Research in particular, I'm very happy to welcome you all to this University of Georgia School of Computing Research Day. So as you all know, this is an exciting and transformative time globally in computing and artificial intelligence, and it is a particularly exciting and transformative time here at the University of Georgia for these fields. We're excited today and throughout the year to celebrate so many exciting firsts and beginnings in these fields at UGA. First, as mentioned, our new School of Computing and all of the interdisciplinary research centers and institutes that it is supporting and housing. Our new director, Dr. Agrawal, who has created this event to bring us all together. And many of our new colleagues who have been recently recruited to UGA through the Presidential Hiring Initiative in Data Science and Artificial Intelligence, really reflecting our strong institutional commitment to establish UGA as a leader in these areas. And as Dean Stenport mentioned, most exciting and promising of all is our students whose ethical contributions to innovation and leadership in these fields, we are really counting on to move these fields forward responsibly in years and decades to come. So thank you all for being here. Finally, I'd like to extend a very warm welcome to our distinguished keynote speaker, Dr. Irfan Essa from Georgia Tech. We look forward to hearing your insights today and also to continued and hopefully expanded continued partnership between our institutions in growing this research area. So again, thank you for attending, thank you for organizing, and thank you for all you do to advance research excellence at UGA. Have a great afternoon.
I'd like to acknowledge, I really shouldn't be, getting credit for organizing this. This is an entire committee in the school that has worked diligently for the last 2 months. Dr. Budak, he chairs the committee, and it's been really tremendous work done by all members of the committee as well as the staff members in the school to make this possible. So thank you to them. And as we are getting ready to move with the I'm actually still waiting for Dean Leo to come in and give his remarks. But before he arrives, I just want to share this very interesting anecdote that actually he had heard from me. So in '96, I was finishing up my PhD at University of Maryland, College Park. And, as we do in computer science, we don't have much of a postdoc culture. So I was applying for tenure track assistant professor jobs. And I think the second interview I had was the place that I would finish up joining for 5 years, University of Delaware. So I go in, I just drive up 90 miles from Maryland College Park, and there's my interview. And about my second meeting were with 2 associate deans in college. And one of them asked me, in your opinion, should computer science be part of art and science or engineering? Now, I figured that there was some political undercurrents to this question that, I wanted to avoid any problems with. So I looked around quickly, and it seemed like there was something saying, PhD dissertation in history or something. So I figured this was College of Art and Science, and the politically correct answer seemed art and science. But it was somehow, foretelling that I would land up to lead a unit which is part of both. So, if I knew of this possibility, I would have said that, well, it should be part of both. And actually at University of Delaware, they were part of art and science. There were discussions to move to College of Engineering. And 15 years later, much after I had left, they actually left art and science and became part of engineering. So these kind of, dynamics have happened, but we are in this very unique situation that we are reporting, we are working with both the colleges, and honestly, I think the collaboration opportunities are tremendous when we do that. Sing a song. Well, that will drive away the audience before your talk. So I only sing to, terrorize people. I'll give it a minute or two. Otherwise, we will proceed with the presentation. Well, let me actually start introducing our keynote speaker. And I'm sorry, will be a little out of order. If Dean Leo makes it here, then. So we are extremely pleased to be able to welcome Dr. Irfan Essa. in the middle of a lot of things going on, including apparently some papers going tonight to CVPR conference. He has taken time to come over here. Dr. Irfan Issa has been associated with many, many important advances in the field. He got his undergraduate degree at IIT like I did, except that this was Illinois Institute of Technology, not Indian Institute of Technology. Trying hard to come up with some really bad jokes. But then he headed to MIT, where he obtained his PhD and worked in the media lab. And since then, he has been with Georgia Tech, starting his career as assistant professor. And currently, he is professor and a senior associate dean, right? He has worked in many, many areas, including some of his interactions with University of Georgia that I just learned in last half an hour on computational photography and media and overall, computer vision, artificial intelligence, and so on. He has been associated with some of the key developments with online education, teaching what are called MOOCs, massively online courses. So in 2013, he taught a class and he was telling me he is running this program, or is teaching programs, classes for a program that has like 13,000 students and so on. His talk title today is very appropriate for the times, very intriguing. Generative AI, it's a little bit hard to miss or avoid that. Chat GPT probably shows up anytime you take a flight and start talking to the person next to you. They say, oh, you are in this thing. What do you do about Chat GPT cheating from students or something? So maybe he will give me a good answer that I can tell next time I'm in a flight. But his title, the title of the talk is Generative AI and Responsible AI. So I'd like to welcome Dr. Issa, and I'm sorry if I have to interrupt your presentation with one of my two bosses arriving, but please start.
No worries whatsoever. And I'll give you a little bit more time by actually taking a few minutes to set things up. Wrong talk. So everybody can see this and everybody can hear me? All right. And again, just let me know whenever you want me to interrupt, because I know how important deans are, and I do not want to get in the way of deans whatsoever. Thank you for the dean and also having you welcome me. Appreciate it. It's actually great to be here and visiting our sister school in the USG. And kind of also, I'm very curious to go and watch some of the posters and learn what's going on at your university in the School of Computing. What I'm going to try to do is give you a little bit of a sense of some of the work that I'm doing. So one of the things that wasn't mentioned is, while I'm also at Georgia Tech, I also work with Google. Some of you who may have driven through Atlanta may have seen that there's a big Google building now in downtown or midtown Atlanta. And it's one of the newer entities that has shown up. And in that entity, there is now, among, of course, software engineers and people who work on Google Cloud and stuff, we also have a research team. And I lead that research team while I'm also doing all of the other stuff, being a professor at Georgia Tech. So I kind of actually lead a very interesting life of being a researcher in an academic institution, hanging out with students and stuff like that. But at the same time, also working with teams that are actually building stuff. So I actually have very successful at kind of making the statement that I have written research papers that have actually been deployed on real systems that millions of people have used every minute. Okay, and that's the key, that while some of my research papers were read by 5 people, maybe some of them understood it or not, but actually the best part of it is we actually deployed those systems out there. Today, I'm going to give you a little bit of a sense of some of the newer stuff that we're working on. But again, Gagan, anytime you want to interrupt, just let me know, okay? So just to kind of give you a sense, my research area is computer vision, which basically is a way of thinking about is how we want to build systems that can see. So what that kind of translates to is that, remember in the field of AI, we're interested in building artificial intelligence. And one of the characteristics of that, and I'll come back to that in a bit, is making machines that can see. Or making systems that can see. Now, I'll show you different sets of examples on it, but this has been the kind of a thread of some of the work my team has been working on, which is how do you extract information from images? Now, one of the things we talk about is cameras. Cameras capture images, and once we get the images, we want to extract information out of it. Now, I know Maria is sitting there. She's actually taught a computational photography class here, which is kind of getting into these kinds of things too, is how do you understand and use images to understand the whole concept of how can you improve the simple aspect of taking pictures and making pictures and stuff like that. But that's been one area. But in that area, we've also been working on things like, for example, on the top, you see this ice skating thing. That's a system that was deployed on YouTube that does video stabilization. The whole process of finding out that these days people hold cameras in their hands and their hands are always shaky. How do you figure out how to improve the quality of that kind of stuff? The other kinds of things that we've done is also look at sports and recognize what's going on and predict what's likely to happen. In fact, just to kind of point out, we have a research paper that starts off with a Wayne Gretzky statement. Some of you may remember it. Good players know where the puck is. Better players know where the puck will be. We actually build a system based on that quote to figure out where the puck will be. That is also in the case of sports and stuff like that. But also in that context, we've done a lot of work on understanding how people move. Then the other part of it that led me to some of the earlier connections is also understanding how content is created, how content is shared, how information is created, how information is shared. And that led to this whole thread of work on computational journalism. And that's why I can spend a little bit of time with your Grady School of Journalism on these types of things. Lots of things. I'm going to give you a few examples of this in my talk. And what will happen is that I'm going to start off with general terms, and for those of you interested, we'll get into a little bit of technical depth, and then we'll come back out of that technical depth into some bigger perspectives. But anytime this is a small enough crowd, you have a burning question, just ask. Raise up, start to get my attention and stuff like that. I don't have to finish my talk because otherwise, I've given enough talks. We don't have to care. So just to kind of say, this is the work I'm going to represent of a whole lot of people, specifically 3 people on my team, Lou, Jose, and Kihok, that work with me on these types of things. I'm going to talk about a whole lot of stuff. I'm going to talk about it a little bit fast. And these are some of the research papers that kind of are represented. I'd like to keep the presentation to be a little bit high level, but at the same time, I'm going to get into a little bit of technical depth. And again, as I said, just to kind of understand what's going on, we're going to talk about it. Now, one thing I always like to do when I give talks like that is I'm going to be oversimplifying a whole lot of things when I talk about things. And also at the same time, some of this will be incomplete ongoing work. One of the things that started happening in the world of AI, machine learning, and computer vision is these days everybody starts throwing at you tables. And I don't know if anybody is in the research area, one of the biggest things that happens in these tables is you compare your work to others, and then you look for the bold numbers. And those bold numbers have to be yours for your paper to get accepted. I'm not going to show you any of those today. But that's the kind of field we're in. It's getting quite competitive. At the same time, a lot more data-driven analysis is going on. If you ask me a really hard question, I'm going to have to phone a friend. Just because, there are some of the details other people did. I just kind of get credit for all of the work they do. So please don't ask me a hard question. With that, let's kind of start talking about AI. Now, most of you have been aware of the field of AI and what's going on. I'm an old person in the field of AI. I've been working in AI since the 80s. Some of you in this room were not even born then. I'm aware of that. And I had the privilege of working with people like Marvin Minsky and Seymour Papert, some of the earlier people in the area of AI. And I've seen it go through its exciting phase. I've seen it go through what has been referred to as the winter. Of course, these days, winter is coming as a good thing. But in those days when we said winter, it meant kind of bad. But Game of Thrones has changed that. But since then, we have actually now have a completely rejuvenation of the field of AI. But it's important to step back and ask the question, what is it going on? So this is kind of a layout of the field of AI. It's a term that kind of establishes itself from 1956 when Marvin Minsky and McCarthy had a session at Dartmouth to talk about what is this whole field. And actually, to be very honest, and I'll talk a little bit about this a little later too, is they struggled with the concept of what they should call it. And artificial intelligence was the name that came up, but there were other names that actually were also very interesting. And one of them was augmented intelligence. But the whole premise was, can we actually build human level intelligence in a machine? But prior to that, there was another whole concept by a person that you may have heard of called Alan Turing. He developed something called the Turing test. The Turing test was to kind of develop a test where a system could be used to compare a intelligent system versus a non-intelligent system. So the basic test was, can you fool a human into believing I'm intelligent? And that was kind of the test that we've been thinking about. The reason that's important is we can nowadays completely beat the Turing test. That is that we do have systems that will, to you in a conversation or any other kind of interaction, will make you believe they're intelligent to the human intelligence level. Now, is that the bar we want to go with? That's something we have to start thinking about. But just to look at the history of this kind of stuff, lots has happened. And there are many things, natural language processing has come in. We've had agents that can speak to you. And, in the recent times, we've even had things like, Alexa and, Google Home and these types of things in your home. And then we have also had things like Jeopardy and AlphaGo, very specific types of controlled experiments where we could really test AI at the large scale to kind of see where things are going and use that to understand what next is possible. So I think that's been kind of where things are. And in this realm, we're going to talk a little bit about, things like transformers and stuff in a bit. But that's where, all of a sudden, ChatGPT has come in. So I kind of find it both interesting and challenging, just like you when I'm sitting in an airplane these days. And in the, 30 years ago, when I would say I was working on AI, they would look at me as like some foreign person that is coming from Mars or something they wouldn't understand. Now I just say AI. Oh, I just used ChatGPT the other day to write my paper. I'm like, okay, fine. That's not just one part of AI, but that's an interesting part of AI. So that's an historical context that's important to build with. But let's actually ask, what is AI? And that's important because I've heard today several times, many of you mentioned the word interdisciplinary. Because AI embodies that completely, just like computing does. So for example, this is just a trade standard definition from Wikipedia. And if you look at it, basically it says, it's about, as I said before, concept of intelligence of humans or animals. And it's the field of study in computer science. And now we have the dean, so I'm going to let him help us explain all of that kind of stuff in a few minutes, and then we'll come back to this one. Is that fine? Keep going? Uh-oh. Well, welcome. Thank you. So just to kind of situate it, it's about intelligence. And the word intelligence is something that, of course, we want to think from a human concept, but at the same time, it touches a whole lot of academic disciplines. It touches, understanding the brain and the biology of the brain, but at the same time, the data that could go into a system, and also how the brain or any other system would create any kind of context or art or something like that. And at the same time, also, how do you engineer a system to build it? So that's why it's a truly interdisciplinary system where it requires to understand humans and humanities and ethics on how you would deploy those types of things. So the spectrum is as wide as it gets. And therefore, it's also something which we are all completely buying in, and so have you, is it's no longer just about the discipline of computer science, but it's about the discipline of computing. And the definition of the field of computing is also evolving. So, you folks have a school of computing. At Georgia Tech, we have a college of computing, which is really kind of aimed at defining this new discipline, which is really aimed at both strengthening the core of the discipline of computing, but also identifying its new frontiers, the frontiers that impact the rest of the field. And it gets into other things, including things like, art sciences, and also engineering and design and business and humanities. And I just now listed all of the 6 schools or 6 colleges of Georgia Tech. You have similar types of things here. And that was one of the reasons I also spent time with the School of Journalism, because where is information? Well, that's in the School of Journalism, and computing has a lot to do with it. So that's why kind of something important. Now, building on that one, and I'm not going to go into any of this kind of stuff, but there are things that we have been actually using for the last 20 plus years that are developed on AI. All of you have now used recommendation systems. Every time you're buying something, it's telling you that, oh, you like this, therefore you might like something else. Or you like this music, it told you you might like something else. That's AI. And similarly, search engines, they're finding through a large graph network all types of things. That's another whole system that's driven by, again, understanding machine learning and AI. So the basic part of it is, it's about understanding content. Again, similar to what intelligence is really about, is trying to understand context. But at the same time, the other part of it is, another thing that AI has been impacting is self-driving. Self-driving is at the core of AI because it's about autonomy. Because when we build these AI systems, we want them to be autonomous. And a car was an example of it. So far, we're still sitting with the steering wheel, but I don't know if any of you have been to Arizona or to San Francisco. You can now sit in a Cruise or a Waymo car, and it'll drive you on a well-defined path without a driver. Complete autonomy. Now, level 5 autonomy is still not something we have achieved, but we do have autonomy showing up. But having said that, such autonomous systems have actually been deployed in other domains. Industrial automation has been there for a long time. So just to point out that this is something that's been going on for a while, basically says is that AI, that computing, is spread across, statistics, operations research, psychology, linguistics, philosophy, neuroscience, economics, across the board, many things going on. Somebody came and said hi to me today who's worked with my son in high school. My son is doing economics research at the National Bureau of Economic Research, and he's doing AI and machine learning. And that's part of it. My other son is working on compiler design for TI. He is actually doing machine learning to optimize compilers. So everybody's doing it. You all are doing it. I mean, it's the name of the game these days. It's the new, people have referred to it as the new, kind of the new electricity, the new oil. We actually have to remind, in fact, I had to remind people at Georgia Tech recently that, don't expect us to turn off our computers at night, because that's like, it's not like turning off light. Computers now need to remain on 24/7 because something is going on and they need to be doing it. Of course, there's scary aspects of computer taking over the world and stuff like that when they're all on it, but that's what, leave that to movies. So again, lots of stuff going on in this space. And the thing that everybody talks about is general intelligence, or artificial general intelligence, which is attempting to build systems that are aware and can do multiple tasks at the same time. We're still far from that, but that's a quest, and we'll talk about that kind of stuff. Just to situate, this is the history a little bit. We won't go into it. I'll come back to it a little bit if we have time. I like this cartoon a lot. So this is a cartoon which basically from the New Yorker, which says, to think this all began with letting autocomplete finish our sentences. Right? We all loved it when we were typing things and all of a sudden autocomplete would finish your sentence. And people who code, this was an amazing tool for us because it would actually start figuring out what we're trying to type before we do it. How did it actually happen? Well, what happened was it started reading all of the written documents we had. Not just mine, but everybody's. This is one of the beautiful things about data, right? And it started figuring out by reading all of those documents is what is the construct of the next possible word. Before we got there, by the way, something we take for granted these days, it was doing spelling corrections for a long time, right? Every time we wrote something, it's corrected its spelling very well. Now, this is where actually I find the whole relationships with machines and computers a little odd. We are always happy when the red squiggly thing showed up and we corrected it and so, oh, thank you. But imagine that we never thanked it for correcting any of this stuff. Imagine telling the computer telling you when you wrote something beautiful, and, oh my God, that was amazing. How, you're really writing much better than you used to. And all of a sudden your spellings got better and stuff. We took that for granted. Now we are concerned when it helps us write paragraphs. But we've been using technology to augment our ability to write for a long time. Similarly, the same thing goes for calculators and stuff. But this is important because now, by reading all of the world's documents, it can finish our sentences. It can learn about how we write. Now, yes, that's scary, and that's where the evil will come up, and now we'll finish sentences and predict what we do and stuff like that. But there are advantages too. That is actually making us more effective at what we do. So that's where ChatGPT comes in, right? It's something which just materialized, I think 2022, December. And the basic premise of ChatGPT, among other things, was a transformer model. I'll talk about that in a bit, but it was an attempt to understand and read all of the existing content out there and use that to build a large language model. And now using that, you could ask it to write, boring letters. Of course, all of us professors have to write a lot of recommendation letters. We were all very happy because, boom, man, I'm going to be able to write recommendation letters fast. It will be much interesting because now the reading systems will also be using our recommendation letters. So what we really need to do is send a token rather than a letter. And we'll talk about tokens too. So that's where I think it was interesting. All of a sudden, it could start generating things. Of course, it got very exciting. The user base of ChatGPT grew to the largest user base in a short period of time. By the way, people forget in this chart, there was one game, a Wordle game, that actually hit the same numbers in a very short period of time. Remember the Wordle game that people still play? New York Times bought it. It was also in the same kind of stuff. People like interesting, creative things. So since then, there's been a lot of work on this space. One of them is basically and this is just a list of some of the products that have come out on these kinds of, projects that have come on in this stuff. People have taken all of this generative ChatGPT stuff, applied it to images, applied it to music, applied it to various different types of things. But the core of it, we have to remember, is until this thing came up, we were spending a lot of time understanding content. Right? Reading content, understanding images. I mean, one of the things you may or may not have noticed that even in the world of Google, initially you just typed in text, but another thing showed up, a microphone next to it. A few years later, another box showed up, a camera. So now not only were we typing in text, we were able to take a speech signal, tell it what it would recognize it. Then it showed up a camera, which meant I could take a picture. I mean, one of the holy grails has been that, everybody who loves to shop likes to do is take a picture. I love that shoes. Take a picture of it, find me that shoe. That's, again, using AI, and that was driven by understanding the content that's out there. Everybody's put out pictures of shoes. Now I can use those pictures of shoes to create a model. And now when I take a picture, it figures out the distance from the one that I took a picture to the one in the model, and tells me this is the closest, and then it says, oh, by the way, this might be a Nike shoe or a Reebok shoe or a Puma shoe, and then basically does this kind of stuff. Something we can do very well. Understanding was the key. But what happened with generative AI was basically brought those tools together to start now creating it. So not only was it giving you, in the case of that example of a shoe, the shoe closest to the one you took a picture of, it would actually now, for lack of better words, interpolate between those two shoes and give you a mixture of those. And now imagine this interpolation, very simplistic terms, could be scaled much large. So now I could basically use this to generate in between different types of shoes. I could now take a picture of cars and I could design a new car or design a new shoe. That would be kind of a mixture of it. So if you remember any of the earlier examples of DALL-E, everybody was talking about this avocado chair. I don't know if you guys remember this, which was an example of, I want a chair, I want it to look like avocado. There's not a single avocado chair anywhere in the database. But it basically took all of the chairs, learned about what an avocado looks like, blended those two, and created a full 3D chair that actually had the characteristics of those. So that's the kind of tools generative AI does. And this is being used to do, of course, all kinds of content creation. Of course, it's also creating a lot of scary aspects of where it could go with this. And we'll, again, maybe hopefully get to that too. So one of the things that's in there, and this is where I'm going to get into a little bit of technical stuff very quickly, there have been new things that have shown up. One is variational encoders, which again, take this data. Remember, when we're reading all of this stuff, we have to figure out the best, simple, compact representation of this. Because if you take it at core value, you would have a lot of data. You need to figure out how to compress it into representative signals. And that's where variational encoders came in. GANs was another whole technology that basically took this and kind of created a looping mechanism to optimize on the value of these types of things. And then came diffusion models. And this is where diffusion models is where you've seen DALL-E and all of those types of things. I'll talk about that in a second too. And also came transformers. Transformers are pretty much at the root of a lot of stuff that went on with language translation. learn from data, find other annotations of that data, connect the dots, do this at different levels, and these are recurrent networks, and use that to represent and understand these types of things, and you can use that to build models. I'm going to skip over a whole lot of technical details. I'm going to show you a little bit of good examples of this, but this is important. The two technologies that are most relevant these days in this whole world of generative AI are transformers and diffusion models. Transformers are neural networks. They're attention-based. They figure out in that attention base is where the most interesting signal is, and then use that in a sequence model that basically, remember when you look at a text string, it's a sentence that's a sequential. It could be a time series model. It scans through this and represents all of those things and extracts from it tokens. Tokens could be bits of information that tell you more about what is the content of that sentence. Diffusion models are a little bit different. They take much more of a holistic view. They kind of think about it as, how would you diffuse something enough? And once you have diffused it, we were to reconstruct it, what would you need to reconstruct it? Diffusion really comes from the chemical process of diffusion. That is, take something, reduce it down to some levels, and then figure out how to get it back to this one. And getting back to the original requires you to learn the model. And that model then tells you a lot about how to generate these types of things. So remember, I did say that first quest, at least in the world of computer vision for me, was you give me a picture, let's say a shoe. I want to be able to then create a label saying shoe, right? And something which we take for granted as human beings. Kids are very good at early age. You show them something, toy, and they say toy. But that's computer vision. Give me a picture. I will give you a text label for this one. But now, once we have enough examples of those picture and text models, can I do the opposite? Give me a text. Can you generate an image? Right? I gave you several examples of avocado chair and examples of that. The other question is, can you give me text? Can I generate a video? You may have seen examples. You're going to see a lot more examples in a bit. So this is the kind of stuff we've been doing in the world of taking the generative AI to the world of images. Generating images that are given by different types of representations, could be just a text representation or something else. So again, technical details, but this is where all of the autoencoder architectures and stuff come in, is give me an image, we will tokenize it, from that tokenize and encode it. We will do all kinds of fun things we do with images, vector quantize it, create these types of tokens. But we also want to do something is we want to be able to reconstruct from it again. So the tokenization is basically compressing this down into very small bits of information that still completely contains the signature of what we wanted to generate it again, except that we want to do this for thousands of images or millions or billions of images, not just one. So we want to be able to create these types of things. So one of the big innovations we came up with this, an algorithm, was that, remember I'd said that initially you could only do this in a sequence. Quick brown fox jumped over the lazy dog is a sequential sentence, and I can do this sequentially. But we basically wanted to do this for images. If we did this for sequentially for images, it would take a lot of information because I have to do scan rate. We want to do this bidirectional. So kind of scan the whole image in one shot. So that's what we came up with, this masked visual token modeling, which was look at those images and scan that in multiple dimensions, extract information, represent them, and it, of course, becomes much faster. This allows us to do various types of things, and this is a system called the Muse system, which allows you to do text-to-image generation with much, much better types of things. Again, I'm in the business of writing research papers. This is a research paper that we have on this kind of stuff. It is fast. It's much faster than any of the state-of-the-art text-to-image systems out there. It's really high resolution, and it's also flexible. I'll show you examples of this. I'm going to skip over all of this technical details, but the bottom line is you give it a prompt. It can go through this process and also can do this at multiple resolutions. So allow you to do small images and large images and stuff like that. Just remember this architecture. We're going to come back to this one just visually because it's the pipeline that's more important. But notice in this is we have text to generate things, but now we can also give it an image to say, improve this image. And we'll come back to that too. So examples of this kind of stuff, and you can play around on the internet with these types of things. Somebody types in 3 flowers, fuzzy, dusk, soft orange, a watercolor painting, foggy lights, soft noise, and it generates something really beautiful. Okay, because it knows things like what is a flower, or at least it knows what images of flowers look like. It knows definitions of what a fuzzy image would be, what dusk images might be, and it knows all of those, and it combines all of them, just like the avocado chair and avocado bring this, but it can only do this at the encoder level, right? That is going to that and constructing it back up. So this, many examples, a landscape photo of New York City with a misty sky. There are lots of pictures of New York City online. There are lots of pictures of misty sky. Now, I can use those to generate it. You should be asking a question. Is there any spot in New York City that looks like this? I don't guarantee it. It might have made up a viewpoint that doesn't exist. We will think about that in a bit, okay? So just an example. Now, as I said, I do work for Google. And one of the biggest things I like to do with this is we take this kind of research and it's showing up in technology that you're using. So here is a simple example. It's something, Pixel 8 was announced about a month ago. I don't know, anybody's bought it. Please don't buy it. Sorry, I don't speak for Google, okay? I just speak for myself. So here's an example of something which you just see is that now you can take those photographs and you can do editing. Here you see an example of somebody moving an object. This is actually on a mobile device, on your device locally. And you can start improving the quality of images. And Maria knows this. We teach this kind of stuff in computational photography. And at the end of it, students can produce these types of things. The thing is, this is actually a product that's running on a commercial level. So here is one of the products in that one was, and we used this whole mass GT framework that was doing whole, other types of generative stuff, deployed it on this one is, given an image like this, I, for some reason, don't like this kid. I don't know why. Well, gone. If you don't believe me, this is the original image. And what we did was we know, both from this image and other images, what couches look like. So when I remove the pixels where the kid is, we can fill in those pixels. Now, in this case, perhaps, I really like the kid. It's not my picture. So you want to do this for good people. But perhaps now you can do this for, you go to the Eiffel Tower, and I was just there about a month ago, and it's really hard for some people to get out the way. Now, there was an older version of this system, pre-generative AI, that would do this, but it wouldn't do a good job. The newer version with generative AI basically now puts only one person and gets rid of the people we don't want. So this is where, potentially good positive examples of getting rid of people that you don't like. And many other types of, how many people have taken images where somebody's just not getting out of the way? And of course, in the old days, when we did without generative AI, it didn't do a good job. It mixed it up a little bit. But now, if you notice, it's hard to tell. Because we know, and again, there are many other pictures of the Sphinx in our model. And we also know what grain looks like and stuff like that. So we can fix these types of things. And by the way, this is purely automatic, running on device on a Pixel 8 Pro. So that's how the smaller models are stuff like that. More examples just to kind of showcase this. Again, initially the previous version, and we're academics. While I'm not showing you tables, I'd love to show other people's algorithms are not working as good as mine, because that's how I get my papers accepted. But this worked very well. And if you notice, it did a decent job of filling out the background with the right kind of foot panels and everything. Bricks and stuff. Another set of problems we had, this is maybe a little hard to see, is sometimes we can detect a person and remove a person. But what happens if the person is holding something, like a bike? So this is an original image, and of course, there are two people that I want to get rid of, but they're on bikes. In the old version, when we did that, it removed them, but it kept the bikes. So we now want to bring in more intelligence to see what connects to a person. And this is where, if you notice, the bikes are gone too. Umbrellas are always an annoying thing. Sometimes annoying kids are part of it, but we don't want to get rid of those. But this is now we can see we can do a much better job of cleaning up these types of things. Here is an example. I was with my wife in Paris. We were actually having a nice dinner, and this restaurant was very crowded, lots of people there. And I asked the server to take a picture, and he took a picture because all of the servers were his friends, so he wanted to take a picture of the servers. I want my picture. Well, this is our picture. Okay, and this is the original. Right, gone. So it changes the experience of how you capture images and stuff like that. So that's an important part of it. Now, yes, it does bring challenges. I'm editing images, which could lead to whole kinds of other problems. And I'm not ever being silent about that. We'll get to that too. So, it looks good to me. And if you really look hard, you'll notice it's not perfect. You can tell where there are issues, and especially people like me, Maria, who knows photographs very well, we can tell. We can easily tell where the problems are. Another similar example, boom. So we can do this kind of stuff well. I'm going to quickly go through a bunch of examples on now changing style. So here, we basically came up with a task that I have this, in this case, the Google Android logo. And, yes, I do respect all of the artists who spend a lot of time building this kind of stuff, but I want to help them out. I want to basically say is, okay, take this logo and now make it have a bird symbol or a dog or octopus or an elephant. Just from that kind of stuff, building these models, we can start generating these. And this is basically now adding a whole new paradigm, that is, we want to separate out style from content. The content was the dog, the style was the Android logo. Can you merge those two separately? And we did this, and again, this is the architecture. I'm going to skip over it. It basically kind of says, if you notice, I added a style parameter to this kind of stuff. This is where I'm basically showing you the people I work with know math. There are a lot of equations here. I work with these people. They're very good at this kind of stuff. Trust me. So here is now, we can do this with style. Given a simple example, style reference image, we can start generating by just saying toothpaste, and it's going to take the style reference image of that pizza dude and start generating a whole lot of examples. I mean, I'm biased, but they look gorgeous, don't they? Okay. I mean, you guys are falling asleep on me. I'm sorry. But, similar examples keep going. We can start generating beautiful designs out of this one. We are showing this to designers. Love this, by the way. Designers want access to this, and it's because this basically improves their workflow quite a bit and scalable. This is very interesting. So that one small figure that you see, that was drawn by Kyuhook, the lead author on this one's nephew. He drew this, and he gave that example, and it then generated all of the other examples based on her style. Okay, one example only. We can actually completely create fonts out of this one. Changes the way we think through fonts and stuff like that too. So many examples of this. We do scalable work. So we generate this for like thousands. This or millions. This is actually a deployed system now on Google Cloud. If you're a exclusive Google Cloud customer on the Vertex platform, you can actually use this out on yourself. So this is available to customers now. I'm not gonna, I work on video. Now let's talk about video. We want to be able to do text to video. This is a paper we wrote, but this is an example of what we want to do with it. Imagine these days we take a picture with our cell phones that just gives us this small sliver. There's this whole rest of the world out there. This picture may not have seen it, but other data has seen it. Use this to generate the rest of the world. And it's a video. And again, many things we can do with this. Give one image, I can generate what the rest of the video would look like, predict the next set of frames. Give 2 frames, I can use that to interpolate between them and generate a video. So it goes from one to the other. In this case, I don't have data on the sides as I showed before. I can now fill in, outpaint, and make it a full image. Similarly, I might have something missing in the bottom here and middle of here. There's a box missing. I can fill it, and it looks perfect. Also, we can do much more interesting things. There are lots of examples of class conditional things like, I have a lot of data of squeezing something. Well, can I now generate just from that one word, squeeze something, a video of squeezing something? Again, this was never done. So again, I'm going to skip over the architecture. It is also really good for compression and all that kind of stuff. Again, you kind of get a sense. Many examples of this one. Beautiful, beautiful. Trust me. It's very fast. Trust me. And we can do wonderful things like this. Videos generated from different viewpoints. Again, video, boom, from one simple example. Again, many examples. I'm going to skip over that because I want to get to something. We can also do actions like the one I showed you. Boom, fast and stuff like that. You know it all. Again, many examples of this. Boom, boom, boom. All right. Now let's see. So we can, of course, also do this with text. So now I can type in panda, mad scientist, mixing sparkling chemicals and an art station. Boom. It generates a short video. This panda looks pretty good, doesn't it? I mean, yeah, the fur could be better, but I'm not a panda expert. So, some of you who might know pandas might know if there's something wrong with these things. But again, similar architectures where we talked about, we can create these types of the Orient Express steam locomotive driving through a landscape in the style of Monet animated oil on canvas. Looks pretty good. Yeah, it does look a little like surreal. I agree. But we can generate these types of things. We love, teddy bears, photorealistic teddy bears swimming in the ocean. I mean, it looks pretty good. So now we can start generating not just images, video sequences out of it. So that leads me to this big question. We need to be very thoughtful about all of this stuff. I'm going to spend just a bit of time on it, not much, but there is indeed a lot to worry about. We have issues around plagiarism and copyright. We're trying to understand those issues. There's another whole category of misinformation, disinformation. Now, I work a lot on misinformation, disinformation. I thought one of the areas that we worked with the journalism school was exactly on that part. But you have to remember that there is a lot of misinformation, disinformation that doesn't use any of this technology. People take a picture from 10 years ago and post it saying this happened today, and it creates riots in different parts of the world. There is no image manipulation, but this makes it harder. I don't know if people saw examples of what happened in Brazil and also what's happening in our country about people making up videos and stuff like that. More importantly, also results is now people can question any existing video as being fake. So that is challenging a whole lot of things. Of course, it impacts jobs. I mean, even with the Writers Guild strike, one of the biggest things they were talking about is, AI is going to help write things, and therefore it's going to make my job harder. So those are important things. And then, of course, the media loves the Terminator, right? I mean, fear works very well. So let's scare the hell out of people by saying robots and AI is going to take over the world. That plays into it. So bottom line with this is, when we create technology like this, we have to develop our understanding of responsibility with it. These days, and this is where School of Computing, College of Computing has to start thinking about it, is in the old days, when the car was being built, about a dozen engineers sat down together, designed it, then it went to an assembly line. There was a whole marketing process, whole lot of things. These days, one of your undergrads could write a poster, go to a nearby coffee shop, develop an app, upload it to a store, and if they're lucky, thousands or millions of people could download it and use it. The concept of responsibility is now back to that level of complete democracy down to an individual. Because in the old days, at least 20 engineers sat down and one could check them for doing it. But nowadays, who's going to check them? So each and every loop code that you write has to be thought through as to what the artifact of that is going to be responsibility-wise. So that's why integrating ethics, I also teach the ethics courses, Georgia Tech, by the way, is understanding how to kind of make people understand the responsibility of it. I showed you a whole lot of tools that could be used really badly. I cannot control what the usage will be, but we need to be aware of them. So that's a large part of the message. I just used this example. This is work we did about 2000. In 2005, I take an image, really nice vacation image, and then I take another image of a cloudy sky. I can use those two to generate this rather ominous image, right, with the dark clouds over it. If you notice, neither one of them looks like the original now, but I can manipulate this and change the message by this subtle editing. And now we have better tools than we had in 2000. This was actually a software paper we wrote many years ago. Now I showed you I can completely change things. So that should both concern you, scare you, but also make you want to think about asking yourself what's going on in this space. Just a couple of big questions here. This is something I really like, is Amara's law. We tend to overestimate the effect of a technology in the short run and underestimate the effect in the long run. This is something to remember. This goes back to when I was showing you the history of AI. AI is around all of us right now. Most of you may not have made it here if you had not used a mapping system, using Google Maps and stuff like that. Google Maps uses one of the most introductory AI algorithms called A-star, which is an optimization framework. It's something, if anybody's teaching AI, that shows up in next second or third lecture. That's pretty much at the core of all navigation systems. So you wouldn't have made it here without. So AI is there. It's actually been part of it. I mean, using OCR, AI. So a whole lot of things. So on the long run, it's been great. But we've actually forgotten how important it is. So that's where we underestimate the importance of it. We overestimate on the short run is we're going crazy about ChatGPT. It's going to take over jobs. It's going to destroy how we do grading. All of that kind of stuff. All true, but there's a lot of hype associated with it too. I mean, I don't know if any VCs are here. I'd apologize, but VCs love to throw money at AI companies. In fact, sometimes the only AI in many companies is the domain name .ai. But it's a great time to be part of this. I also like to show this example. As I said, I work in computer vision. This is just about when I was born, 1966. Some of the leaders of computer vision and AI wrote a summer internship project. This whole summer internship project in one summer was to solve the field of computer vision. One summer and 2 months, they were supposed to solve the entire computer vision problem. This is how bad they were at estimating this. I mean, 40, 50 years later, about, the computer vision, the conference that I think was mentioned, has about 7,000 people attending it. And none of the problems of, yes, we have commercial value. I showed you some of it, but it's still an open question. So many examples of that kind of come in. Another thing I always like to say, remember, I did augmented intelligence. That's an important thing for us to start thinking about. This is a variant on a statement that I make now is, ask not when or if AI will replace people. Ask when people using AI will replace people not using AI. And that's an important part for us to start thinking about in this context too, because, we got to create those tools that make us more effective. So again, not to offend the writers, but writers can actually use those tools to make themselves better. Like the designers could use the tool to make themselves, focus more on other types of things. And that's an important part of what I'd like to kind of see us do. That's more of a positive statement. And this, one thing is these days we get a lot of confusion about what is AI? What is machine learning? What is data science? All of them are part of the real same ecosystem. To me, my personal bias is AI is like a long-term goal. General intelligence, can I understand human intelligence that I can replicate it in a machine? If nothing else, it'll teach me more about my own intelligence or human intelligence. To me, data science is a technology, as a rocket that is going to get us to the moon, AI, and machine learning is the rocket fuel that is going to get there. And so they're all integrated. I didn't get computing in there, but computing is the infrastructure that's going to help us get there, right? So I think that's why this whole multidisciplinary field is what excites me, and that's where we need to do a lot more work. With that, I love these quotes. People love to predict the future. I just like to build it. And most of the time, I try to do almost no judgment as to if it's there, but I do want to remember that we need to be responsible about it. With that, thank you so much. I'm happy to take any questions that you may have.
We do have time for questions. Maybe if you don't mind, maybe use the microphone.
And I have a lot of cartoons. I have one more up here.
So I have actually a few questions. In the first slide, you said you predict where the buck is or on the game. So how accurate is that one? Do you actually look at emotions or what do you do? The second question is me because I have to go back, right? The second question, how do I know that when you create a video or an image, is that fake or not to the people? And I think for the people to understand, maybe you want to have a software that predict or at least tell the people this is fake, because it's costing these days lots of problems, maybe people dying because of this.
Very true. Very true. So first, let me answer the first question. So in the field of machine learning and AI, we create these what we now refer to as baselines. And we compare all of our output to baselines. So I'll give you an example in the case of, so this was to answer your question, how do I know if the prediction is right, of where the puck is? We actually, in most cases, in case of sports at least, I know eventually where the puck was because there was a score or not, and I can compare it to the raw data to see if it was exactly that or not, and actually can validate my algorithm, which is very similar. Remember, in the world of speech recognition, we had the speech and text and people annotated all of the outputs. And then I can compare my algorithms down to the fidelity of those approaches and measure the assessment of these kinds of things. So now I feel it's gotten mature enough that we've completely gone data-driven. I sometimes also think that perhaps we've gotten too mature that we've actually gotten ourselves enslaved by these kinds of assessments, that we're basically only building algorithms that beat the past baselines. And this is something that's happened in speech recognition. But the bottom line is, as scientists, when we come up with these types of things, we have to evaluate and test it. Your next question about the, kind of this whole question about how do we know what's fake and what's not. So yes, we are building systems, not just myself, the community, of detecting fakes. There are ways of doing this that kind of start looking, and one of the ways again is looking at natural images. Looking at a lot of natural images, we can now build a database of natural images. And now we can also generate fake images. So basically, by combining those two, we can create a database of annotated real images, annotated fake images, and create this whole model that allows us to verify those types of models. So there's a whole lot of additional stuff going on. But having said that, I mean, it's something we have to be very careful of, again, because this is like an arms race, right? So remember, before we get into this fake images, there was another arms race that arguably we may have actually managed to survive, which was the spam game. Right now, most of us are not seeing as much spam on our emails. But it's a race, right? Because as soon as the system develops best way to figure out a spam, the spammers figure out how to beat it. So it's a constant arms race between, and as long as there is a value market for creating spam that gets through to your inbox, so you would click and therefore secure your systems, there will always be people developing that. And similarly, as long as there is a value of generating fake media, there will be people generating these kinds of stuff. We got to be diligent. We got to build tools. And as I said, we are building tools to detect those types of things. And also look for, in fact, one of the earliest things YouTube did, by the way, 2005, when it actually did this, was start looking for copyright infringements. I don't know if anybody uploaded any images to YouTube, almost 2005, 2006. It would start saying is, oh, no, you can't upload this. This is image copyright. It's a very similar technology to be able to find existing things and compare to it and say, nope, we won't do it. But having said that, have we won that battle? I don't think so. I hope that answered your question.
Software, or they are not scientists like you are, to actually check if it's correct or not. They just run with it.
Absolutely. So I have a student from Nigeria, and he basically is doing a lot of work on exactly misinformation on that axis. And the example he uses says is, my family living in this part of Nigeria gets this information. They just take it for face value. They do not test any of it. But we got to build systems on their, access mechanisms to allow to do that. And that's exactly the kind of stuff we're thinking about this. When it shows up, and Brewster Kahle, the founder of archive.org, used to say is, what's the best way of verifying information is showing this information from different viewpoints. Google News was based on that kind of a concept, that it was a platform, collected news from everything. So if you ask saying riots happened on this street, it would show you 5 different viewpoints of this one. Now, user beware still applies. The user has to read all 5 of them. If they just read the first one, they might get misinformation. So that's a tricky thing, but bottom line is it's a slippery slope. Next question. Thank you.
My name is Prashant Doshi, and thanks a lot for the talk, Dr. Essa. I think that was a great talk. I've also been teaching AI here since almost 20 years now. Well, I've been teaching since 17 years, but been in AI for 20 years. And so I've gone through the winter, I've at least heard about the winter you mentioned and so on. So, if you think about AI right now, right, there are some areas where, we have superhuman level AI, correct? Like playing chess, for example. like for example, the best software in chess is right now, I think, Stockfish, and nobody can defeat Stockfish, right? It has a yellow rating that's way above any human yellow rating. So now looking at all the computer vision examples that you presented, sort of the thought that crossed my mind is that this is really great. It's definitely better than what we have been doing so far, but I still don't feel like it's at a level where it can exceed a talented artist, or it can exceed a talented photographer to be able to, do the in painting, the out painting, the interpolation, and, the style transfer and all the things that you mentioned. Like if you take that cheese guy running and you tell him, okay, draw a mouse in that style. Yes, I think a talented artist can do it. So like, do you feel like, we are going to be entering an era soon where it's going to be like sort of superhuman level type of computer vision, superhuman level type of, I don't know, like image generation, where I think that, or is that even a concept like in computer vision? I think that's the better question.
So I mean, the best answer I can give you on that one is, the examples of where we've done very well have been well-defined, unified cases. Like, let's be very honest. We know chess is a, forget what ordered something search problem. And we can build optimization tools to search in the future and find possible solutions and kind of adapt dynamically. And, one of the things I remember as a graduate student, we were at the MIT AI lab, and we were all talking about the future predictions of machine learning and AI. And Mitch Tenenbaum, who used to run SRI, came in and he basically told all of us was, when I came to MIT in the 80s, early 80s, there was a robot called Polly. It would move 1 inch, take one image, think for about 5 minutes, and move 1 more inch. That Polly now runs real time, and this was 10 years later. So in essence, all vision people could have gone to the beach and come back because Intel basically solved your problem by making you a better processor. Thing that happened with Go, and we got better processors that can now make those large-scale problems tractable. Now we can learn from those optimization systems. But when you start getting into vision, it's a much more global, large-scale problem. Vision is a much more complicated. What we can now do is basically do 90 to 80% of the initial work. So in the case of Style Drop, what I showed is I'd love to use the designers as being their initial dashboard. So it does the initial work for them. Similarly, for the video stuff, for the creator, I would like it to be their initial collection of curated content that they can use to generate something. So I personally believe, and that's what I kind of said, is it's going to augment the user to do tasks that they're better at. We basically want to get rid of the mundane tasks. When the calculator showed up in the 70s, in those era, all of us old enough people were memorizing tables. And I know all of us were complaining, or at least our parents were complaining, oh, you guys are going to use calculators. Nobody has to memorize. Maybe we didn't need to memorize those tables. The current generation doesn't, right? They take for granted. The question now is the next generation not going to be writing papers? Well, I don't think ChatGPT is going to replace Shakespeare anytime soon.
Well, I guess, my question maybe, now that I think about it more based on your answer, is also about creativity. And whether, is there like a goal in computer vision to exceed, human level creativity in, for example, in generating images, generating videos, and so on, right? So is creativity a benchmark in computer vision?
I think some people would say that's a benchmark. Pretty much, remember, all of the stuff I'm showing you, I can say generated in the style of Picasso. That is because Picasso existed. It doesn't generate in a style of somebody I did not know existed, because I could use Picasso's examples. So the question still comes up is, in this interpolation world, are we going to generate new things that are, quote unquote, again, simplistic defined in the space of things interpolating right? Is it going to create a new tool? I mean, I argue some of these things are the new paintbrush.
So can it generate the next Picasso? Can it generate the next?
It's going to help the next Picasso generate newer, more creative things. I hope. That's my hope.
Hi, I'm asking this question not from a computing perspective. I'm in the Department of History here and also in the Dean's office working with Dean Stemport. And I wanted to go back to your point about responsibility and how it falls on the individual now because development is so decentralized, unlike the automobile manufacturer. How do you as an educator see the possibilities for inculcating that sense of ethical inquiry as part of the process of educating the next generation of
So
computer
I
scientists?
teach the ethics class at the undergraduate level for a long time. I have a minor in philosophy myself. And I must tell you, when I teach that class, I'm sorry, all of the undergrads in this room, there are a few, they hate me. Because, I mean, I could be writing code right now, and you're making me learn about how, Immanuel Kant was thinking about the, various ways of doing things, and what does cultural relativism have to do with this kind of stuff, and why do I need to know this? I assure you, when I run into the same students 3 years later, they're like, oh my God, thank you. Because when I'm developing code, I'm thinking about what impact it would have on others. So I'm not saying that's one answer, but that's one answer, is inculcating that fact that, you need to think about what you're doing with this kind of stuff. But having said that, there are challenges. I mean, one of the things I also cover in my classes, anybody who's done any ethics, maybe you've done this, is we cover the trolley problem. There's choices you have to make and these types of things. There was a beautiful example of the trolley problem when autonomous driving, right? So in the case, somebody asked Mercedes executive, you're building a car that's autonomous. The trolley problem is you're going down thing and you have a choice of killing one person or three. And one person is you and the three is other people, or something like that. The same thing is very interesting in the case of autonomous driving, right? Mercedes is selling you the car, the owner, and the choice Mercedes has to make is, who's it going to save, you or the three people? And the Mercedes executive made the statement, of course, it's going to save the driver.
Just solved that problem.
Bad answer, right? But that's the kind of thinking as to we have to kind of start. And also we have to start asking questions of what should we be deploying? What kind of testing should we be doing? That goes to the question that was asked, is we have to do robust testing. I mean, I'll give you so many examples of this one, and people are misusing technology to no end. So anybody who's read the book Weapons of Math Destruction? In that book, there's an example of how the appellate court system of US uses this database to give sentence recommendations. Of course, it's a completely biased data set because it's using existing flat data sets, which of course are biased because there is a different type of people in prisons than not in prisons. So of course it gives bad sentences, those people who look like people in those sentences. But that is required on not just the individual, but societies that are looking at deploying these systems to ask questions. I was just at the Symposium for Health at Emory just 2 days ago, and we were talking about all of this kind of stuff. And one of the bigger questions is, I mean, we have to build trusting systems that work reliably before we can deploy them, but we also have to thoroughly test them. We have to put in principles to understand, because the impact of this is much broader. So I believe the initial impact of AI is going to be on things like entertainment, because usually nobody gets hurt. But then we start going towards things like fintech, people get a little bit more hurt. Then you go towards health, people get a lot more hurt. So I think the bar on responsibility has to pop up more to make sure to validate. But again, I don't want to claim that I have the answers, but this is part of the conversations. And that's why we also need to work with people from history, ethics, and other types of sciences, both natural sciences and human sciences, to understand this. And that's why this is a cross-disciplinary quest.
Thanks.
I may have deferred that question pretty effectively, but that's what it is.
Hey, great talk. Thank you very much. I'm Aditya Shinde. I'm a fourth-year PhD student. Towards the end of your talk, you mentioned that at the very least, we'll learn how intelligence works, even if we don't get to general intelligence. And I was wondering, how are we really, heading towards that goal? Like, have we learned anything about the theory of vision in humans through whatever recent advances in deep learning or machine learning, have happened? And to add to that, Jeff Hawkins, controversial figure, he had this famous book on intelligence. He came up with a follow-up book, and he was very critical of the fact that, modern computer vision can replicate a lot of the way we think the brain works, but it does not have a concrete theory of vision yet. Do you have any opinions or thoughts on that?
Oh God, how much time do you have? uh, I mean, the bottom line is every effort we make, we learn more about ourselves. Sometimes we learn about the anomalies of what we do things. So, Ted Adelson, a person I worked with at MIT, he was very well known to figure out where human vision fails. I mean, there's things like, you look at things and you see shapes that don't exist. I mean, human vision fails that, forget computer vision. It's not going to even get close to that kind of stuff, because one of the things we have is experiential systems. We can experience things much, much better. But there are lots of unknowns in our world. So I'm actually completely driven by understanding how humans see things. And, I worked a lot on facial expressions and stuff like that. Still to this day, I mean, anybody has a young child, pretty much in the first day, you walk up to them and they can lock onto your face. What is that innate? It could have been developmental things. Of course, you smile at them, they smile back. We don't know actually if they're feeling good or they're just passing gas. But we know that mirror neurons work. So we are learning a lot of these types of things by doing pure scientific study into these types of things. Is it helping us understand the human vision system? Yes. But having said that, that's a positive trend. The other trend of just kind of going, and this is what I was also referring to, is this data-driven quest of kind of beating the past algorithm is also causing problems, because we're now basically just fighting algorithms. We're not fighting the science. So in fact, one of the things Bill Freeman, a good friend of mine, a colleague of mine who I work with, used to say that, in this new world of vision, we should be learning more about the human vision system. But then came these large language models. And we have completely gone into this other direction of trying to understand everything that could be labeled in large language models. And we're forgetting to spend time understanding how labeling happened. And by the way, labeling is a problem on its own, because labeling basically says is I take everything and I put it in different categories. By the way, putting different things in different categories is great if that's the task. It doesn't actually lead to understanding. It just basically means I categorize things. So those are higher level questions that I could talk for hours, and we can engage and brainstorm and perhaps even hurt each other.
Thank you.
Hi.
I can keep going for a while. You have to decide when to stop.
Yeah, if you are okay, we'll keep going.
Okay. Okay. So.
Hi, I'm Ari Schlesinger. I am an assistant professor in the School of Computing here, and I have a question that I suspect will be relevant to our students. So one of the things you were talking about is responsible AI. And so when you start a new project, how do you apply that responsible ethics to what you do? What are some of the questions that you ask yourself and your students before you begin a new project?
So one of the biggest one is, what impact will certain things have? What are the use cases, and how would it change different types of scenarios? So I'll give you a very concrete example on this one. Anybody know? And I do work a lot in photography, right? In photography in the 60s, there was this something called the Claire charts. Anybody seen the Claire charts? The Claire charts were pictures of, and remember, where was most of the photography development happening in those days? Kodak, Rochester, New York. Most of the, and in the photography process, what happens, you take a picture and then you go into a darkroom. This is darkroom photography. And then you have to expose the film correctly to get the right kinds of colors. Claire charts were charts given to you to kind of look at when you would do this. All of those Claire charts were white people, because Rochester, New York, 60s. And I use those types of examples, is that we can't start with a bias model. Project Douglas that Google did recently has spent a lot of time building a database that actually represents the skin tones a bit better. And so that kind of shows lessons learned from the past to lessons what we can do. Another example, and I blame myself for this, I developed one of the earliest systems for human expression recognition in the early 90s at MIT. It was really good at recognizing expressions of 20 to 24-year-old Asians and white males. Wonder why? Because that was my data set. I mean, that kind of stuff won't fly anymore.
Yeah.
And that maturity has finally come in. So using those kinds of examples is saying is that, you can always fall into pitfalls by looking yourself in a myopic things. Now, having said that, don't worry about developing new technologies, build them, because let's be very honest. The other thing I always tell everybody is, perfect is the evil for good. You can't start with a perfect rendition and not develop something. Develop it, but when you start testing it, deploying it, start asking all the hard questions. Start asking how you're going to collect the data. Start asking how you're going to test it and make it robust. And also start thinking about it, what are the negative uses? Now, having said that, I also want to be, and this is my personal opinion, we want to start worrying about not doing just putting a red ribbon on our shirts. So these days, all conferences in machine learning and AI want you to write a responsibility statement. It's 2-liners. It's now basically could have been generated by ChatGPT. It's just people are putting a red ribbon. And we need to be careful of that. So again, I'm in the quest with you.
Yeah.
I'd
Thank
love to
you.
be able to figure out how to do this better. And if you have ideas, please tell me.
Happy to chat.
Thank you.
Yeah, sorry, running out of time, but great talk, by the way. I was hoping you could speak a little bit more on the, I guess, technicals on how you might train some of these models that you put up earlier as far as like number of parameters, right? So like in vision problems versus like NLP, the difference in parameters, like the trainable models we have now are, orders of magnitude in difference, right? So, and especially as a small research lab like us, how can we get to the level of like Google, say, in, compute power to train these kind of things? So can you speak on what is current as far as what is being done at places like Google, and then B, advice for research labs like ourselves and how we might be able to, produce similar work to somebody like, Google Research Lab?
So a great question. And again, many different examples come up to kind of help us understand this. But anybody know the new version of ChatGPT? How many parameters does it have? Any guesses?
I know the last one, or the last I looked, it was like 1.7 trillion or something. I don't know what
So the
current
new one
is.
is somewhere near 4 trillion. Okay.
Why not?
The video results I showed you, 1 billion. Take a long time to train. Now, we have built an efficient system that actually works. In fact, that was part of our code algorithm, was to kind of reduce the model size. And then we got it small enough to be on a mobile device, at least the image one, not the video. But that's a big problem. And as you've heard by now, also challenges that enough of these systems will take over the planetary power supply. And those types of things. So that's one part of it. But the other question that you're asking is that it's becoming an interesting game. I feel really privileged that I can now work in both aspects of the world. I can work in academia and industry. It's a tricky world, and any of the leadership people that, people from the research office, please figure out a way to kind of open those pathways, and, because we need to figure that one out more and more, because there's no way we're going to get the compute in universities of that level. I was, again, privileged enough that I was able to build a compute engine at Georgia Tech that matches, at least for about 3 months, the one we have at Google. Then it went out of whack also. Bottom line is, we have to start defining how to do newer class of work. So one thing could be, well, everybody's running around to answer this big question about foundation models. And is this talk being recorded?
I think it's live stream.
On YouTube. I'm going to whisper this out now. I have my doubts about if there is going to be a foundation model that rules them all. It's not going to be the Fellowship of the Ring, one ring that rules them all. There are going to be many different foundation models. But I could be wrong. I've been wrong before. But the other part of it is there's a whole lot of stuff to be done that's at the downstream of those foundation models. And that's what I like to do in my academic environment, is kind of take on some of the challenging small footprint problems, and then kind of start working those out, and then figure out collaborations with bigger entities to do the large scale ones. And, hey, reach out to me if there are opportunities. One of my charters in the Atlanta office as I run it is to connect more with the at Georgia Tech, Georgia ecosystem, not Georgia Tech, Georgia ecosystem broadly. And, I'd love to connect with people at here. We're connecting, of course, with Georgia Tech. I'm biased, I'm there. But we're also connecting with AUC, Georgia State, and other types of things to connect more broadly to support it. Compute is a problem. And actually, you will find it surprising. It's a problem in industry right now, too. Because, companies are not producing hardware fast enough to do it. That's why we should have all bought NVIDIA stock.
Yeah.
But yeah, cop-out
Thank you so
answer,
much.
but it's there.
Well, thank you so much to Dr. Esa for working in very latest technologies. We have a gift of a very old technology, SWAP. And I started getting worried from your talk that, I hope you will put it in your office or house. Office? What's that? So you don't have an office, okay. And you will not, you will not edit the image or maybe do a replacement and make it a Georgia Tech blog or something. So with that, oh, okay. It's gold colored though. Yeah, so it's kind of a mix. But you can edit and provide any color you would like. No, we had built in the time. So our AI model predicted a lot of questions.
Well, good afternoon, everyone. First of all, my apologies for being a little bit delayed. I made the mistake of scheduling a faculty meeting before this where we talked about balancing teaching and research, and so that ran a little bit long. I'm going to take a wild guess, and when Dr. Agrawal said the dean is not here, there weren't a lot of people that got him and walked out, right? I came to see the dean, right? No, anyway. I'll make my remarks short. First of all, first of all, thank you to Dr. Esa for coming, giving that fantastic keynote. I want to thank everybody for coming this afternoon. Welcome you on behalf of the College of Engineering, the University of Georgia. Thank Dr. Agrawal, all the people who came who worked to put this session together. I think as we all know, and especially after that great keynote, this is an incredibly rich area. I don't need to add to that. I couldn't add to that, but it's so exciting. I think this is an incredible time that we're talking about these issues. I have to be a little bit selfish, and I think that it's something where it's an incredible time at the University of Georgia. I'm so excited to see in the last 10 years the growth of our engineering program, which now has about 2,800 engineering students. 15, 20 years ago, that was about 250 students. I'm incredibly excited about the collaboration that we have with the Franklin College of Arts and Sciences now with the School of Computing. Very excited that Dr. Agrawal has joined us. To me, the University of Georgia is changing. It's becoming much more of a STEM institution. About 40% of the enrollment here of 40,000 students or so are in STEM disciplines. 10% of our enrollment across campus is in computing and engineering. And so everything you heard Dr. Esa talked about, everything you'll hear talked about this afternoon, I'm so excited about because I think these are the types of problems that we should be working on. We should be working on them in engineering and computing, but we need to be working on them in journalism. We need to be working on the history. And I think the University of Georgia as an institution is a great place to do that. So if you don't mind, I'm actually going to stay. I don't know if I paid the registration fee, but I'm excited about what we're going to talk about this afternoon and looking forward to the rest of the conversation. Thank you very much. Oh, okay. So, so as dean, we are paying for this. That's okay. Thank you, everyone.
Seems like I have done my MC duties. We have a coffee break now, and we'll have some students take over for the trivia competition. And you really want to stay up for the trivia competition because this morning I stopped by Kroger. Every correct question you will get a chocolate bar. And there are 20 questions, but 27 chocolate bars, so the organizers will eat the rest.
Let's make an announcement saying that we're gonna begin shortly. So please take your seats. Who all are doing this? So Lalita and what's his name? I don't know his name. We don't have to know their name. Oh, okay. We can just be
Oh,
like.
you don't know
can,
his name
no.
either? Okay.
Can we please give them the mic or hand over the mic to them? Yeah.
You know what? Let's ask.
What is his name?
Prithvi.
Prithvi. Prithvi or Prithvi?
Something. Forget.
When will the people be back? We can start maybe.
I think maybe you guys should start speaking a little bit so that people will come in.
Sure.
We don't want to.
Okay.
Should I start? Yeah.
Good evening, everyone. If you would please take your seats, we are going to start a very exciting phase of this evening. Please take your seats. So it's kind of like a tradition for the SoC Research Day to have like a trivia session. And usually we have a lot of fun. It's a short trivia session, mostly based on computer science. Some of it is based on UGA, Athens. But it's going to be fun. So please take your seats and we'll start shortly.
Maybe we can just start with. You have this. Yeah. I think we can start now since the team is also here. I think they will say something.
So now we are going to start our trivia session. I am Kriti Ghosh, and I have here with me Ms. Shravya Kadur.
Thank you for all being here today. We've got an exciting activity planned for you, a computer science trivia. Are you ready to test your knowledge?
So let us go over the rules first. So firstly, obviously, no cell phones, please. Secondly, when we ask the question, please raise your hands if you know that you can answer the question. And our volunteers will go to you once we pick you, and they will give you the microphone. And then you tell your name and the answer. Also, for each questions, there will be a maximum of 4 attempts. The first 3 attempts are reserved for students only. So, SoC students, go team, yeah? So, try to answer the question, any student in the first 3 attempts. If you cannot, then please, everybody else, anybody, faculty members, please, you're most welcome to answer the questions if you know the answer. Sorry about that.
Without further ado, let's start our computer science trivia.
So, question one, are you ready for it? Are you ready for it? Cool.
Okay, so the question is, which famous computer scientist and mathematician is known for developing the concept of a universal machine, which laid the foundation for modern computer architecture?
John von Neumann.
Yeah.
John von Neumann.
Not exactly. Anybody else?
My name's Rohan, and is it Alan Turing?
Wow, we have the winner for the first question.
Alan Turing was an English mathematician and computer scientist. Turing was highly influential in the development of theoretical computer science, providing a formalization of the concepts of algorithm and computation with the Turing machine, which can be considered a model of a general-purpose computer.
So now, the next question. What do we have? Ooh, I like this one. What type of neural network architecture is used in the GPT models, like, ChatGPT?
Transformers.
Well, once again, we have our winner. Give it up for Dev. Next question.
Which blockchain platform was developed to enable smart contracts and decentralized applications?
Hi, my name is Basanta, and is it Ethereum?
Ooh,
Yeah,
of
you're
course,
right.
Okay,
it is.
thank you.
Looks like the faculty has no chance here.
Yeah, well, we School of Computing students, we rock. So the next question. Interesting. Who invented garbage collection in programming languages? Okay, I was just bragging about our students. What happened to you guys?
We can make the question open to faculty.
Anybody? I mean, honestly, yes, it is. We have a winner. So, John McCarthy was an American computer scientist and cognitive scientist, and he was one of the founders of the discipline of artificial intelligence.
Moving forward to our next question. There have been quite a few UGA mascots since 1956. Can you tell us what's the name of the current UGA? This was a relatively easier question.
Hi, my name's Catherine, and is it Boom?
Yes,
You're
we
right.
have a winner. So, Boom is the 11th UGA mascot.
What is the oldest remaining structure on the UGA's historic North Campus?
So, Shruth?
Is it the old college?
Yes, it is. It most certainly is. So, well, the old college is the oldest building in Athens and one of the oldest in northern Georgia. The building closely resembles Yale University's Connecticut Hall. It currently houses the Franklin College of Arts and Sciences.
Moving forward to our next question. What was the name of the first electronic computer? Okay, we have, yeah.
Apple One.
It's not really. One more try. Ooh. Okay. Cool.
ChatGPT, no, I'm just kidding. IBM.
Not really, no. Sorry. Anybody else? Um, sorry, could you please repeat? Close, but no. Yes, actually, it's ENIAC. So ENIAC, completed in 1945, was the first electronic computer. It's an abbreviation: Electronic Numerical Integrator and Computer. Aww. So we move on to the next question. Okay. So which company has the highest market share for GPUs?
NVIDIA?
Yes, that's correct. So NVIDIA dominates the GPU market with more than 80% market share.
Moving to the next question. Who was the first woman to win the Turing Award? Looks like we have a person.
Oh, hi, I'm Akila. Is it Marie Curie?
No, not really. Anybody else?
Yeah.
Is it going to be your second win? Let's see.
I don't have a chocolate.
Oh, you don't?
Margaret Hamilton?
Not really. I'm sorry. Not really. Anyone else? Sure.
Grace Hopper?
No, sorry. So, open to all. Anyone? Woo! We have a winner. Yes.
Fran Allen was an American computer scientist and a pioneer in the field of optimizing compilers.
So our question number 10. Which two Turing awardees are known as the fathers of internet? Oh, we have a hand.
I'll just try. I think it's not right, but is it Sergey Brin and Larry Page?
Sorry, no, it's not.
Yeah, I knew it was not correct.
Anyone else? Anybody want to try? Going once. Oh, we have. Oh, wow, we already have the answer. Please give it up for Dr. Esa. So yes, Win Cerf and Robert Kahn designed the software code that is used to transmit data over the internet. Dr. Cerf and Dr. Kahn have been at the forefront of a digital revolution that has transformed global commerce, communication, and entertainment. Next question.
What are two different animal species that have been UGA mascots?
The bulldog and the goat.
Whoa.
Wow,
We didn't expect such a
we did not expect. So, honestly, for us, we did not know. And it was, wow, great. It's the right answer.
Sir William, a goat, was the first mascot of UGA. UGA has had two bulldog breeds as mascots, the White Bull Terrier and the English Bulldog. Moving forward to the next
Go dogs.
question.
Yeah. Next question. Name the first social networking sites. That was a typo, but anyway, the first social networking sites that were launched. Oh, we have a hand.
Is it MySpace?
No.
We have another hand.
We have another volunteer.
Friendster. Friendster.
No.
No.
Wow, let's try everything. Anyone else? No.
Usenet.
No. Okay. Maybe then anybody else? Okay, we have one more hand.
We can keep the chocolate if they don't answer.
Yeah, we love chocolates.
Is it AOL?
Sorry, it's not. Well, maybe we can give the answer. So, 6 Degrees and Bolt. Both were launched in 1997. So, yeah, they were the first social media networks. Next question.
What's the name of the open source software utility framework for big data storage and processing? We also have a hint. It's named after a stuffed toy elephant. Think of all the...
It's very, very easy. Please. We have a hand there.
Is it Hadoop?
What is today with Vasanta? We were the winner. Yes, it is Hadoop. So it was named after Doc Cutting's son's toy elephant. That's a picture. Next question.
What was the material for the first mouse invented by Dog Engelbart? Yeah.
We have a hand.
Wood.
You're right.
Yes.
You can go ahead.
Doug Engelbart invented the computer pointing device, a mouse, in 1964, and it was made of wood.
2 years from now, spam will be solved. A famous comment made in 2004. Can you identify the person who made it?
It's a really fun question, and the answer also.
The person is also very famous.
Very famous.
You can just guess.
Any guesses? Ooh, we,
We
have,
have
a
one.
hand.
Yeah.
Is it Steve Jobs?
No, sorry,
No.
it's not.
Is it Sergey Brin?
No.
Do you have any more tries? No, sorry. that is
Yeah, that
actually
is the
correct
right
answer.
answer.
Yes.
Yeah.
So
A spam-free world by 2006. That's what former CEO of Microsoft Corporation Bill Gates promised, and now it's 2023.
Yeah. So the next question. Oh, this is very easy. Who is the CEO of OpenAI? We have the hands there. Oh. Okay.
Is it Sam Altman?
Okay. Okay. Yeah, so what's the answer?
Sam Altman?
I mean, okay. Uh, okay, so yeah, my latest information is not true anymore, but um, so what do we do? Um, yeah, okay, so yeah, Samuel Harris Altman is an American entrepreneur and investor. He was the CEO of OpenAI and was the co-founder of Loop. He previously was the president of Y Combinator and was briefly the CEO of Reddit. Next question.
Who coined the term metaverse? We have 3 hands.
Is it Mark Zuckerberg?
Not really. Close, but not really. Not that way close, but anyone else?
Oh.
Oh, wow. Yes. So
the term metaverse was coined by Neil Stephenson's 1992 science fiction novel Snow Crash, where humans as programmable avatars interact with each other and software agents. Similar to what Mr. Mark Zuckerberg once said, in the book it was mentioned that the metaverse would be the successor of the internet. That is how you were close to the answer.
So the next question. Who won the 2022 Turing Award? Any hands? Anybody want to try?
Now the question is open to all.
Um, yeah, no. Anyone else want to try? Oh, we have. Oh, cool. No, sorry, it's not. Anyone else?
Had something to do with Pixar.
I mean, so we can go with the answer. So Robert Metcalfe, also known as Bob Metcalfe, Professor Emeritus in the Chandra Family Department of Electrical and Computer Engineering at the University of Texas at Austin, was named the recipient of the 2022 Association for Computing Machinery SCM-AM Turing Award for the invention, standardization, and commercialization of Ethernet.
Moving forward to our next question, and thank you, both of us have a chocolate.
Yeah, we now have chocolates.
Who is the youngest recipient of the Turing Award?
Mark Zuckerberg?
No, not really.
I think we can give him a chocolate because he was.
I mean, we should.
We can give you a chocolate because everybody laughed at your answer. That was a funny answer, though.
Any other try?
So it's Donald Knuth. The youngest recipient was Donald Knuth, who was 36 when he received the award in 1974 for his work on algorithms and computer programming.
Well, he was when he received it. Ooh, the last one. So, what is the fastest supercomputer in the world? Oh, we have a hand.
Tesla Dojo.
No, not really. Sorry.
We don't want another chocolate. We would fight for it.
It's very close. It's in the top 5.
That's the second
but,
one.
Really short. Any other try? It's the last question, guys. 1 second. They're all in the top 5, but okay, I can give you a hint actually. Yes, could you please?
I don't remember the name, but it is at Oak Ridge National Lab.
It is at the Oak Ridge National Lab. Anybody could guess the name now? So we have an airlines named similar.
Yeah. Yes.
Yes, that's the correct answer. So as Dr. Taha said, Frontier is kept at Oak Ridge National Laboratory, and it's the fastest supercomputer there is. So yeah.
And that concludes our computer science trivia. Thank you all for being such an amazing audience. We hope you had a great time testing your knowledge. Ladies and gentlemen, please join me in extending a warm welcome to Dr. Shannon Quinn. He serves as the Associate Professor of Computer Science and will also be moderating our panel discussion today. Dr. Quinn, the floor is yours.
I think the floor is mine and 5 others, if I believe. So if the other panelists would like to come up and take your seats, and then I can introduce you all, because I'm not actually the interesting one today. I'm just going to introduce them, throw out something controversial, and then sit back and let the sparks fly. Excellent. Well, let me briefly start by thanking the students for that wonderful round of trivia. I really appreciated that. That was awesome. I learned a few new things, including that Mark Zuckerberg won the Turing Award. I also want to start by just preemptively thanking our panelists. Honestly, it was a lot of work kind of getting everybody together, and I think we have a group of some really awesome folks who know a lot about this area, and I'm really excited to hear what they have to say. So very briefly, I want to introduce Dr. Irfan Essa, our keynote speaker, who hopefully you all heard earlier, distinguished professor at the School of Interactive Computing and a senior associate dean at the College of Computing at the Georgia Institute of Technology, of course, my alma mater. Professor Dennis Duma, an associate professor here at the educational psychology at the University of Georgia, within the program for gifted and creative education, as well as the quantitative methodology program. Professor Khalid Rashid, professor in School of Computing at the University of Georgia, and the director of the UGA Institute for Artificial Intelligence, and the director of the Evolutionary Computation and Machine Learning Lab. We have Dr. Ari Schlesinger, an assistant professor in computer science at the University of Georgia, who got her PhD also from Georgia Tech in human-centered computing. And from user interface design to software engineering, Ari is interested in socially engaged computation to effect equitable social change and technological advancement. Finally, we have Dr. Kimberly Van Orman, who is a lecturer in the Institute for Artificial Intelligence. She teaches courses including AI, ethics in AI, philosophy of mind, and cognitive science. And her research area includes philosophy of mind, her research areas include philosophy of mind, philosophy of science, and the ethical implications of AI. And she is also the chair of the Teaching and Learning Committee of the American Association of Philosophy Teachers. So, a really awesome panel, and we're going to talk about AI and its role specifically in higher education. So let me start by painting a picture. A beautiful fall afternoon inside the Georgia Center at the University of Georgia. A panel of experts in artificial intelligence and higher education, a large conference hall, cinematic lighting, atmospheric lighting, photorealistic 8K HDR. For anyone who has not had a chance to play with AI or wasn't there for the keynote and the mention of Muse, or has played with generators like Midjourney, Stable Diffusion, DALL-E, Adobe Firefly, what I just said is an example prompt for the underlying algorithm to create an image. This is a simple example, but that's my point here. AI right now is as big as it is in no small part because it's accessible to a large number of people. I can give Midjourney $10 a month like I would Netflix and generate all the memes, or use my Pixel 8 to show my wife and me alone in Times Square. I can log on to ChatGPT and ask it to generate questions for a group of panelists on the role of AI in higher education. I can log on to Amazon, Apple, Netflix, YouTube, Etsy, and get product recommendations for every holiday or event. The genie is out of the bottle. AI is here to stay, and higher education is no exception. This goes, the quote that Dr. Essa had, ask when people using AI will replace people not using AI. AI is here. So to open discussion, you're all researchers, and that experience is relevant, but I'm specifically addressing everyone's instructional hats. I'd like to start by asking everyone, how has AI impacted your instructional or educational experience? And what changes, if any, have you made in how you teach? What challenges have you encountered as a result of AI, and how have you adjusted, or what ideas do you have to adjust? I could call on somebody. I would say let's start with our keynote speaker.
Considering I was just told that I would be on this panel 5 minutes before.
Excellent.
So, as by now everybody may have guessed this, I'm a little bit of a maverick nutcase. And in that context, in my teaching right now, I've actually been using auto graders for a long time. And the auto graders, by the way, I teach large classes. I've been teaching computational photography and computer vision to about 500 people online for the last 8 years now. So in those classes, a couple of things we basically, we've already been doing this. Everything that's been submitted goes through an auto grader, goes through some sort of a plagiarism detector, goes through code reviews and stuff like that, extensive amounts of things which we have built into the infrastructure. Now, when ChatGPT comes in, everybody's of course asking the question that people are now going to use ChatGPT to generate code. My answer to that is very similar to the old equation of, when we were, I gave an example of calculators, right? When calculators came in, everybody started saying, oh, calculators are not going to be allowed in exams anymore because people are going to use those types of things. But I'm not testing their ability to use a calculator. I'm also always assessing their ability to solve problems. And basically what that means is I'm changing my problems to the extent that I'm still assessing their ability to solve problems. Not their ability to memorize things, not their ability to rotify or trying to kind of just come up with those types of specific things that come out through standard processes, and I'm basically raising the bar. And that's my methodology on this one, is we're basically changing that it's no longer the code quality that we're measuring. It's no longer that their ability, but we're changing the stuff that they can't just generate, but they have to put in the thought process, and sometimes also creatively express the thought process as to how they solve the problem. And doing this at a large scale that we do is challenging, but it's something which we've been very successful on. And basically, we always look at is, what are the outputs that they generate? Now, having said that, working in classes like computational photography and computer vision, the output is usually an image, or its output is some sort of an artifact. It's not a code. And yes, they could go to DALL-E and generate the final artifact, but there's a whole thing called the process of making it. And that always showcases how we do it. So when I used to teach a video class, we used to have everybody generate a video, but then I added one assignment is you have to also make a making of video of how you made that video. And the construction process, you cannot fake. So that was always my answer.
Okay, I guess it's difficult to follow, Dr. Isa. But actually, for me, I teach courses that are relatively small in enrollment. Like the machine learning course is 8,000 level, evolutionary computation is 6,000, 4,000. So I haven't used generative AI in my courses, but that doesn't mean I wasn't affected by the revolution in AI that is going on in recent years. And that made me change my curriculum in machine learning completely, like a couple of years ago. And I keep changing it every year. So I think the field is evolving very quickly. But I intend in the future to use more generative AI in preparing my course material and stuff, because the traditional way of teaching is becoming challenged, if I might say. So I think we have to become more creative in our evaluation in particular, like how do we assess the learning of the students and stuff like that. I think there is a lot of room for using generative AI and AI in general. I also want to emphasize that there is more to AI than generative AI. So right now, I mean, like if you stop someone in the street and ask them, and I think Dr. Isa alluded to that, they would say, yes, I use ChatGPT and stuff, but there is more to AI than that, and there is a lot of role for machine learning and for in teaching in general for any course and any subject. I think we have to integrate AI in the teaching in general of all subjects in all disciplines. With that comes the responsibility of ethical AI. So everybody has to learn about ethics in AI as well. And I'll stop at that.
Hi, okay, so I'm Ari again, just as an introduction. And when I think about this question about AI in the classroom, I think it's helpful to take a step back and think about why are students in the classroom in the first place? And what is it that students are hoping to get out of being in the classroom? And so part of that is an open dialogue with students about what are you hoping to get out of class and how can you best support your learning towards those goals? And that gets into questions of intrinsic motivation and extrinsic motivation. And so if you want to use ChatGPT or some other AI product to aid you with your work, is that helping you achieve the goals, the learning goals that you have for this class, the goals that you have when you're in a higher education environment and the types of education you're hoping to get and how you're hoping to apply that? Because at the end of the day, how much you learn is sort of up to you, and what you put into a class is often what you get out of the class. So that isn't necessarily a direct answer about using AI in the classroom, but it does help inform the ways that I think about it and the ways that I would encourage students to think about it. Another way that I approach this is how is it that we are spending our time together in the classroom, right? And so you can't fake with ChatGPT or other AI technologies the classroom time and the activities we do in class. And so instead of lecturing and sort of the students are an empty vessel to pour knowledge into model, how do we do activities where we're constructing knowledge together and students get the chance to apply and think about these ideas in the classroom, where you can evaluate live on the spot sort of where people are getting stuck and what problems they're having. So that's sort of a high level, quick answer as to how I think about ChatGPT and other AI technologies in the classroom.
I like that. It's really heavy and it's really nice.
Yeah.
You could
Heavy
probably
notes.
just.
For stability.
Yeah, it's very nice. My name is Dennis Duma, and I'm actually not in the School of Computing. I'm an associate professor in the Department of Educational Psychology. And I think about this issue maybe as like a meta educator in a way. I am an educator. I teach classes here at UGA. And I also, my lab and I, we study learning in classrooms. And what we're doing with AI is, well, I guess just to back up for a second, kids come into school with a whole gamut of differing psychological attributes. Yeah, everybody knows that. And it's educational psychologists that assess the individual differences in students and then match those students to the services they need to do their best. So it might be extra attention from an educator for extra help, or it could actually be extra challenge that kids need, depending on what their psychological profiles might be. But we actually have an issue going on in the United States where there's not very many educational psychologists, and educational psychologists currently, usually there's only one of them for a whole district or maybe even a cluster of districts, and they really can't sit with every student in order to determine their needs and get individual education plans written so that teachers can understand these kids. So what we're doing is we're using AI models in order to build essentially a virtual psychologist assistant that can sit with every child coming into elementary school, see what they write, see what they draw, and make judgments on the psychological attributes that are present in the work that students do, and then make recommendations for students' IEPs to teachers. So that's what I use this technology for in my lab. Actually, though, my personal teaching so far, I don't know if it has really affected it. At least mostly I'm teaching seminar courses where maybe there's 10 people in the course at most. And the discussion is really rich. I think it's rich at least. And if someone has a misconception, it comes out pretty quickly in the discussion. And then we fix it right there. As an educator, it's much simpler to build knowledge in a student than it is to fix a misconception. It's sort of like the difference between exercise and surgery, I guess. But if a student has a misconception, you can fix it right there in a seminar. So actually, it hasn't really changed. Maybe it's changed the demands on the grad students because they have to learn more stuff that you guys might already know. Like psychology grad students have to learn a lot more computing processes now in order to be competitive. So that might have changed what I do. Anyway, I guess I'm rambling about myself, but so you know who I am.
I just wanted to add, I am jealous. You folks have only 10 people in your classes?
Yeah.
How did that happen?
These are grad classes. Yeah. In my department, usually our undergrad classes are capped at like 25, and our grad classes are under 10.
If you're not careful, we're going to start having classes in here because we need bigger rooms.
Well, maybe you guys are more popular than us.
Hi, I'm Kimberly Van Orman. I'm in the Institute for Artificial Intelligence. And let's see, this spring, I think classes started on the 9th or the 11th. 2 days before classes started, I decided I had to switch to a contract grading system from my previous system, which I never recommend changing 2 days before the semester starts, like the whole structure of your class. But the problem was, prior to that, I was already having kind of massive amounts of cheating issues. And I think too often the standard of the way kind of students perceive their teaching is as a kind of competition with the teacher, right? How much of a grade can I get from them? And I never wanted that anyway, But I was having cases where even on homeworks, people just look it up on the internet and then not even change the answer from the internet or check to make sure that they were using the same variables that were in the problem, right? So I thought there's no way this is going to go well with now having ChatGPT. So that was a huge change. And I explained it to students. So they basically can kind of pick how many of which assignments they do and by passing all of them. So at the undergrad level, they can pass at an 80. At the grad level, they can pass with an 85, but they have to do a ton of stuff to then get up to an A. And the idea is 6 months, a year after the class, right? This all, I think, requires us to go back to our course goals. I want them not to know this for the exam. I want them to know it a year after they've taken the course. And I know I was a student who in some cases could study my butt off the night before, pass the exam, and then wash it out of my hair the next day, right? And I wanted to make that not be what my students could do. And that where they felt, I felt a lot of our students also, it's very high stakes for them. They're on scholarships that require them to keep a certain GPA. A lot of them have the self-image of a smart person, and to try something different and fail then is not just, I've messed up my grade, it's now who am I? I'm not the smart person anymore. So trying to set up my class so that there were places where they could make errors and still recover their grade, where it wasn't like a competition. So I've totally had to like rework my class. I'm still working on it. Haven't figured out how to use ChatGPT in my AI class yet. It is not the large language type of AI class. But I think that's coming. I'm also one of 4 people leading a faculty learning community on how are we going to teach with AI? Because especially for those of us, I'm coming from a humanities, part of the process of writing in the humanities is about clarifying your thoughts, not necessarily, especially at this stage, creating the product. ChatGPT is great at creating products. You have an email to write, let it do it. But if you're trying to create knowledge or you're trying to understand something, too much offloading of that is absolutely circumventing your own learning. So I'm trying to figure out where we can draw that line so that we can figure out where, kind of like Ari was saying, where are the good places to use it and where are the places and how can we motivate students and help them see why the work is worth doing? Because learning hurts. Like if you're really learning, it should be really uncomfortable at times because you don't know how to do it. And I worry that with AI, students are going to too easily offload things that they shouldn't offload because it's easier and because it feels better sometimes, right? So kind of getting them focused on the process and not the product, I think is a big aspect of what we're going to need to figure out how to do with AI.
That's a great segue into something I've heard before from AI researchers and fellow instructors who said that AI like ChatGPT isn't, even though it may look like it's breaking the traditional classroom model, that's actually not what's happening. What's happening is it's revealing weaknesses in how we approach evaluation in particular in higher education. What Ari said about students being empty vessels to pour knowledge into, like that's clearly not what's happening. And you all gave great examples of exactly this. And so probably pretty confident in saying there's no Professor ChatGPT on the horizon, but what does evaluation look like and assessment look like moving forward? How do we assess student knowledge and learning so that we know we're doing our jobs and so that they don't go and wash the knowledge out the day after an exam? And maybe from a research standpoint, is there some way to encourage these kinds of models to do, as you said, Kimberly, help stratify and organize thought rather than produce products, if that makes sense?
Well, I think, oddly enough, people like him have been studying how people learn for decades now. And sadly, a lot of us who teach haven't paid any attention to it. And I think we're at the point where we kind of have to. So like one of the best books for this, there are a couple of really good ones. One is James Lang's Small Teaching. One is Ambrose et al., How Learning Works. There's also a national research center, maybe. It's Bradford et al. Do you know that one?
Yeah.
It's something like How Learning Works. It's a very similar title, but How People Learn.
Yep, that's it.
And these are ones that do like talk about what actually motivates students. So one of the things that like authentic assessment comes up. I used to work in a teaching center, so I used to do pedagogy like full time. But kind of understanding both what motivates students and how do we get them just one of the images of a faculty member when I'm back in my old job used to talk about, I feel now like it's me and the students against the stuff, where it used to be the students against me and the stuff. And I think that kind of shift is like, at this point, that's what we have to have. We have to have the students feeling like we are the people that are going to help them be successful at this. And so some of the simple things are frequent low stakes assessment, but that could be an in-class activity where they have to produce something, where just doing it gets them credit, but then you can give them feedback on it. They need lots and lots of feedback on their progress. And our students aren't used to that, so you'll get pushback originally. There's lots of research on this too, right? We have some of the best and the brightest students, but what that means is, to them, they'll say things like, no, look, learning is where you talk and I listen. And if you try to push them off of that, they get anxious, because now I don't know how to succeed. So the things like communicating how they can succeed a lot is another way to try to help manage that. So I think all of these sorts of things need to happen, and I'll shut up now.
So let me kind of ask this in a different form, or convert this into a question. So, the problem most of us have is we've never been taught to teach. I get in front of people and I lecture, and hopefully something good comes out of it. But thankfully, have been now engaged with other people who have helped me teach. And in that one, I've kind of also learned a few things. And one of the most important thing to remember is there's no one size fits all, right? There are different types of learners. They learn different things, different ways, and stuff like that. So the question I have is, and it's a kind of a holy grail question, is we've gone, at least in many instances, larger classrooms and more of this lack of the Socratic method, more of the lecture method kind of stuff has come into play. Is can we bring in AI now back to going towards a little bit more personalized education? And what I mean by that is, remember, one of the holy grails of AI and one of the earliest projects in AI were personal tutors. Now, are we going to be able to deploy some of those because we know a little bit more about AI than we did before? So that was my long question.
That's a good question.
Anybody can answer.
Anyway. Well, we're going to get the audience in just a moment, but yeah, any thoughts up here?
Well, let me try. So I think you mentioned a great possibility, and that is for AI to deliver personalized education. And I think that we have come a long way. I worked in a system like for automatic scoring of exams or something in the 1980s. So we have come a very long way from that. It would need an initial investment. We would have to redesign the way we teach completely in order to benefit from these systems. But the personalized education experience would be wonderful. And I think it could try to fit what you said, that or someone said, that different people learn in different ways. So we cannot fully adapt to every possible learner, but an AI system can. So I think we could benefit a lot from doing that, but it will require an initial investment, a significant initial investment.
So there is, I'm forgetting his last name, but a professor at Brown who teaches programming languages and does CS education research. His first name is Sriram. And he has so he's got his lectures for his programming language course on YouTube. And in his first lecture, he introducing the field of programming languages. And somebody asked something about how there's an online version of the course. And he says, well, what you all in this classroom are getting is the real value because you have access to me and the TAs. And so his, he's like, the content is out there. So, but the real, at least from his perspective, the real value was that individualized instruction, the opportunity to catch a misconception in the classroom and get feedback from instructors. And so I don't personally think that AI is going to come in and create this like holy grail of individualized instruction for all students, but I think what we ought to be asking ourselves is sort of what is AI good at versus what are people good at, and how do we best leverage that combination, right? The people who are using AI as opposed to not using AI. And so there are certain things that AI is going to be better at, and especially when you have a large classroom of 500 students, you need to be able to leverage something like an auto grader for some of your assignments. And so the question really just comes down to what is the best balance? And perhaps it is, perhaps part of it is in sort of differentiating where individualized instruction is necessary, such that, which I think is part of what your research is about, so that we can identify and then maybe cluster students to give that more individualized instruction. And that could be a really exciting opportunity for AI. Is that close to what you're doing?
Yeah, pretty close. Yeah, teaching, it seems like there's a lot of like under the surface stuff about lecture versus hands-on learning and things like that in higher ed. Teaching when prior knowledge in the students is low is really different than teaching when prior knowledge is high, really different. And that's one of the reasons why people appear to learn differently, because they have different amounts of knowledge, different amounts of motivation, different personalities. And then, so even though the learning processes that benefit everyone are often, well, it's the same way that we all heal the same way, and like a doctor would treat us all pretty similarly. I'm talking about an MD. We need our teachers to treat us all the best way. So actually, one of the things probably you've heard some like snake oil stuff from the 90s about learning styles, right? Like this, there's visual learners, kinesthetic learners. This is, I've never seen a study that has any evidence for this. And I've seen a lot of studies that have evidence that directly contradict it. It's actually a huge problem in elementary schools because students get identified as kinesthetic learners and they get sent outside to shoot basketball hoops while the other kids learn multiplication tables. But these activities don't have equal societal value and don't have equal value going forward through your schooling. So instead of thinking about people learning differently, think about their profile of abilities they bring in. Do they have more or less knowledge? Do they have more or less motivation? Do they have more or less capacity to engage with each other, like in like an extroversion sense? And for that reason, we can differentiate. Geez, I hopefully I'm not just, I think about this stuff all day. One note on assessment. I think assessment might be pretty different in your college versus mine. In the social sciences and maybe particularly in College of Education, grades have been inflated so high over the last couple decades that there's not really any variance produced in students by giving tests anyway. Actually, maybe now that I have tenure, I could actually fail students and not lose my job, but it would be very, very, very odd in my college to give low grades at all, actually. And that makes giving assessments largely a performative box to check. And the assessment actually doesn't function as a measure in any way. So there's really no reason to even do it. If people are going to create their responses via ChatGPT, or whether they're just going to think them up because the test has been written so that everyone can do pretty well, the whole thing is sort of a waste of energy, actually. I know the culture is different in different colleges. Like, for example, in law, grades are really, really important. Yeah, it sounds like it might be here too. But it's not actually the same across campus. Assessments mean completely different things. And maybe that makes you envious of these students, but I don't think you have to be, because when you lose objectivity, you also lose the capacity to make good decisions about students. So I think actually in the social sciences, we've backed ourselves into a corner of such extreme grade inflation that there's not really anywhere to even maneuver. We can't tell if kids are cheating or whether the test is just so easy because we've written it to be.
I was just going to say, I didn't know I was doing it right. Thank you.
Yeah, you are.
I don't care for assessments. Waste of time.
I want to kind of disagree a little bit. I think the role of assessments is not just to say who gets an A and who gets a B, but it's part of the educational process itself. So, and some of my students are here actually. So in the homework, the questions are meant to get them to review certain material and to exercise certain processes that help them in learning. So it's not just the grade that's important, but the process itself of going through the assessment shapes a little bit the learning experience. That's my take.
Yeah, I want to kind of follow up on that because I think in faculty development and probably in other areas of pedagogy, we often talk about formative and summative assessments. Summative assessments would be your exams, your papers, your projects. Formative are everything else that gives you information about their learning and gives students information about their learning to provide feedback. And sometimes your summative can also be formative. Sometimes you have a small grade on the formative just to help students prioritize it. But I think, yeah, thinking about assessment as the whole set of learning activities is a helpful way to think about it.
I'll just follow up really quick with one of the ways that I think about assessment and then AI and cheating is if you take out the motivation to cheat, right? Why do students cheat? Well, they cheat because they want to pass their class. They cheat because they're overburdened. They cheat because they're worried about being judged. So what are some of the ways that you can reorient your class so that, okay, so if you just do the work, you get the grade. So how do you reassess motivation and sort of, there's larger questions there, but I think there's some interesting questions to be asked about why do students cheat and how can we remove that motivation?
Yeah, I'll follow up on that because that's why I changed my course. So students can, in some cases, drop things. They also have 2 tokens that they can use to retake an exam up until the last exam or resubmit a homework up until the last homework. So again, it gives them a chance to fail, but use it as a learning opportunity as opposed to, because my experience with the cheating was it was the rare student who just didn't care and just didn't have any interest. It was 9 times out of 10. Somebody who thought they had enough time to do it, realized that they didn't want to get it late, and so did a Hail Mary and cheated. So I have an automatic 3-day extension because I'm rarely starting grading the day I get it. So I have a Google form that as long as they admit by the day it's due that they need the extra time, they can get 1 free 3-day extension. They can use their tokens for extensions or they can use their tokens for retakes. And I told them as long as I could manage this, and so far I have, but if it was going to become unmanageable, they'd get 3 tokens and then everything is by token. And it just it just relieves a lot of that pressure that was causing them to cheat. And I think it changed the relationship because I'm getting way more students coming to office hours because they get that I'm trying to help them learn and that they get that this is no longer a competition, but that I'm going to do my best to make sure that they can learn the stuff because I think it's important and I think their learning is important.
So just another kind of a thought thing that I had, I'm jump into this one. College students, what's the most visited website they're known to go to? And I can tell you they're not adult sites.
Chegg.
Yeah.
And this is pre-ChatGPT. Most college students go to these sites to ask somebody to do their homework. And it's been a known fact for a while, and I don't know how ChatGPT has changed.
I had somebody do that during an online exam. That was the last time I gave an online exam. They used their name.
we know, everybody knows what sites we're talking about, right?
Chegg.
Basically sites where you basically ask somebody to do your homework for you.
And you pay them for that?
Yes, it's paid sites.
Like motivate them, like if you upload one of your exams or your assignments, you get tokens to take more from what we have.
It's a nice deal.
You know, when I was at Ohio State, there was an incident where there was a Craigslist advertisement that marketing something, can someone who looks, you know, Caucasian, about 5 foot 6 inch, no mustache, you know, available to take the final exam for me, good compensation assured.
So just as a point on this one, you have to be careful these days because I have a colleague of mine who's been trolling these sites and he's trying to figure out who are doing assignments, who are posting his assignments on the site, and he actually has found many students causing this.
Well, I was about to say, I feel like this actually might be a good opportunity to start allowing for audience questions, given that we already seem to have started a discussion, and we can start with, so if you have a question, feel free to start getting in line at the microphones, but let's start with Lakshmish right here.
Thanks for an interesting discussion. My question is probably linking the keynote and the panel. Probably to Dr. Isa first and then to everybody. So when I heard the talk, especially about...
It looks like it's not working, Lakshmi, so raise your voice.
I can raise my voice.
Yeah, that's good.
So when I heard the panel, the keynote and the panel, so one of the questions, especially with large language models and generative AI, was I brought back to me the only philosophy class I took where I read John Stuart Mill, where he talks about the tyranny of majority. So now, for those who don't know what tyranny of majority is, that the large group of people in a democracy can essentially smush the minority opinion. So large language models, when they collect a lot of data from everywhere, are we at the risk of doing that in large language models? And especially when we do it when we use these sort of tools in classroom environments, are we, rather than individualizing, are we basically making everybody the same? You learn, this is the way. So one of the examples I can give you is go to any computer science, I'm working in the systems community, go to the systems community conferences. Every paper is of the same structure. There is an introduction, there is this, there is that, there is this, evaluation, this structure is essentially the same. Why? Because we have learned that structure should be the same for that paper to get accepted. So do you think this is tyranny of majority in play? And how do you address it?
I defer to my esteemed colleagues.
I have so many thoughts on this. I won't go too long because I'm sure she does too. So I've seen a linguistic analysis of the output of ChatGPT. I can't find it, but it basically, if you look at the sites that we suspect, so if you look at the sites in the Common Crawl, which we suspect is part of the training for OpenAI, essentially ChatGPT has the voice of a 20 to 40-year-old white North American male, right? So it has the same kind of opinions, thoughts, it tends to start from the same place as that group. There's nothing wrong with that group. But I think this idea of tyranny of the majority, if people are using that to get their ideas, it's like if you only ever spoke to your dad, right? That's gonna shape the language you use, it's gonna shape the things you consider, it's gonna shape all of that. And I have real concerns that if we continue to do that, I'm wondering what it'll do for creativity. I'm wondering what it will do for people kind of going outside the box. Like, have we just created another box that people have to work within? And I think that idea of the tyranny or the majority is a really good way of kind of helpful way of thinking about the limits that might be built into the training data.
Go ahead.
No, I was just gonna say, so it's very dangerous that regular, like non-scientific users, they just rely on the base model. So they just ask questions and get answers. But for researchers and students, we can do better than that. And I was in a defense this morning, and the topic was how to take the base model and do additional training or give it a context and then get better answers this way. So, and the easy way is to give it a context. So instead of asking ChatGPT, how do I solve this problem? You would give it like some background material, like the chapter, for example, and then ask it, given that, how would I solve this problem? So I think this way would go. Of course, it's not going to solve the problem because many people would just be lazy and just use the base model as is out of the box. But at least for researchers and our students, hopefully we can do better than that.
Maybe if I could add, so I was not really thinking about that. So my question, I think, may be, for example, if we start using large language models, both in classroom or outside classroom, are we at the risk of losing certain dialects, losing certain way of speaking? So, for example, my own language back in India, it has 20 dialects. If it is all trained on material from classic literature or the people where newspaper articles, etc., are from one region, the other dialects will just vanish in a couple of years. So is that a problem if we start doing that in classroom? That is where I was getting.
I'll just say that not just the bias that Kimberly was talking about, but the English language bias in general in large language models is a very well-established problem area, and the inability to work with other dialects is huge. And this is not, I suspect that part of what you're getting at is the way that these types of technologies can sort of exacerbate and upscale pre-existing problems, right? So how many people like Star Wars in this audience? Do we, right? How many people know that there is now a version of Star Wars that's available in Navajo? It's really cool, but Navajo is a dying language. Well, there's many dying languages in this country from indigenous peoples, and that these technologies can only exacerbate the speed at which these problems exist. And so I think it's a fair question, but there's also this larger societal question of like, well, maybe we need to be doing more movies and having translations into other languages that are at risk of disappearing. I don't know if that's the answer you were looking for, but I think it's a fair question.
And actually, it's something to be watchful of, but at the same time, it's hard to predict evolution the way we kind of think through. So I'll give an example. I was just some of you saw pictures. I was in Paris recently, and I've been to Paris many times. And all of a sudden, this time around, I speak a little bit of French, but not much. I speak a little Spanish, but not much. But this time around, usually in Paris or in France, when you started speaking French, they wanted to talk to you in French and they didn't like it. They were upset at you, but they'd still talk to you in French. All of a sudden, everybody was speaking in English. And I asked around what's happened. And basically what's happened is the whole French system has moved towards watching Netflix. In the old days, they would not Netflix with subtitles, but now they're actually watching it in English. So all of a sudden, their ability to speak English has gotten better. And now all of a sudden, they're willing to speak English, which, as I said, as a person who's there, I wanted to practice French, and nobody would want to speak French with me. I don't know what caused that artifact, but those are the kinds of things that are happening. But at the same time, this is an opportunity perhaps to use language models to revive Navajo and other types of things. And I think those opportunities both exist on both sides. There are things going to change. As I joked around why are we writing letters that eventually going to be read by an automated system to write letters? Why don't we just send a token, which basically has a number and we're done? Send a QR code. We have to figure out those mechanisms.
Over here. Yep.
Oh, yeah, I just really great points. I really love the discussion. I was waiting for you guys to finish up. Love the point you made. Yeah, anyway, my question is, you were talking earlier about ways that AI impacts teaching. I was about the whole panel discussion. I really like the point that you made. I forget, I guess which you made it now, that assessments, really kind of lost value at a certain point, at least in your discipline. And one of the things, the biggest change for me as a grad student, undergrad versus grad, is in undergrad, you do kind of a lot of busy work, a lot of things that you do because you have to, and there's a lot of meaning behind the assignments. So you lose weight. And I've used Chegg, I've used other things to expedite those processes because I didn't feel like the work was valuable. So I guess my question and also challenge is, going forward, how are you guys planning on using AI not only to make your work more meaningful for students, but I guess how will you integrate AI and kind of what are the plans to do that kind of thing? Because for me as a grad student, now I like grad school because I get to do meaningful work. And that's what's important to me. And that's why I don't really use ChatGPT. I do, do the hard work because it's meaningful and makes a difference for me. So anyway, just, I guess, a little bit of a rambling question, but succinctly, how do you plan on using AI and integrating it to make work meaningful for students?
So one of the things I do, and I have a few students here too who can tell you whether it's successful or not, but I'm more moving toward, there's a whole movement called transparency in education. So a lot of times we know why we're asking you to do it.
Right.
You don't know why we're asking you to do it. And it's obvious to us. So some of that, and I definitely need to get better about that in some areas, but trying to say, here's what I'm hoping you will learn from this. And I think, okay.
It's back.
It's back. But I think some of that is part of it. And I think one of the things I have been doing a lot of is metacognitive work, which is asking students, how is this working for you? So one thing that students have come back after the semester to say that was amazing to them was reflecting on an exam. What did you do to prepare for this? How did you perform on it? How did that work? Because again, because our students are so smart, a lot of times they don't have study skills. So that's the other thing, is even if they wanted to do the work, they don't know how. If once what they normally do fails, they don't know what other options to go to. And a lot of them won't ask for help because they think that means they're not smart. And so they won't do it. So like even doing things like that, helping students figure out how to attack the material in ways that might not be their natural way of working, or their native way of working, I should say. I don't know. We'll see if that helps.
It's not my phone, is it? Whose phone's dinging?
Mine doesn't make that noise.
I got mine on Do Not Disturb, so I know it's not me. Anyway, I'm just chastising you. I think your story is really compelling, and I think a lot of new grad students tell the same story, and it matches my own lived experience too. A lot of high ability learners really are eager for tasks that they see as meaningful and authentic, as in that it can influence the adult world. They don't want to be segregated from the adult world. And the flip side of that is that really high ability learners can also develop bad habits, like you mentioned, because they see their tasks as segregated from the adult world. They see it as not real, and they approach it in a way that they wouldn't if they actually cared about it, to say it bluntly. But if you do that for a decade, middle school, high school, college, or something like that, all of a sudden, that's how you do it, and you can't change. That track is worn. And I have this experience with my new grad students. When they come with me, most of them want to go into academia. Academia is very, very competitive in psychology, and their writing and their analysis has to be really, really good. But if they treat it like they treated their master's level or their undergraduate level coursework, the work's never going to get published, basically. I don't think we do a service to students by making undergraduate that segregated from the adult world. That would be the word I would use. But that's the way it is right now. I don't control it. But once you get to the point where you're doing authentic work that can influence your adult professional identity, that's when you want to drop any bad habits you've learned already. Otherwise, they definitely will hold you back. It's just another thing. And possibly those bad habits could be, ChatGPT or something like that.
I'll just say really quick that I think one opportunity to use AI and to help with the authentic work is to ask students to use something like ChatGPT to generate an answer to whatever the homework is and then have them critique it. Because being able to understand what makes a good answer versus what makes a bad answer, sort of in any discipline, is some important higher level critical thinking that is meaningful.
In the category of, I don't know how to answer your question, but I'll answer the one I know how to answer. Overall, I'm, very cautiously optimistic about AI in the education system. I don't just mean the classroom, I mean in the education system. And, again, while we're talking about higher education here, remember there's a huge challenge of education at the 2 to 12, 10, K to 12 phenomenon. And we also need tools for educators to be better at doing education. And I think AI is going to have to play a role in that one. There is another set of roles that AI will have to play, which is not just in, assessment and all those things, but is also advising. In fact, you can play around with this one right now. And you can go into any of your Bard or ChatGPT and say, I'm a freshman at UGA. I want to take a degree in computer science with a minor in philosophy. Can you generate me an entire 4-year syllabus? It will hallucinate a pretty interesting syllabus. But that kind of stuff can be fixed. It can be made more real. And more importantly, you can also start defining ways of not just assessment, but criteria to assess how they're doing those types of courseworks and stuff like that, and kind of provide not just feedback to the individual, but to the advisor or to the professor. And I think those kinds of things are the ones that might be a little bit more customizable, but at the same time, there is always going to be a person at the end trying to engage with this one to kind of satisfy all of these types of things. And I think there's a lot of optimism I have for that kind of stuff.
Can I just quickly add, thank you for saying that after the deans had left. Otherwise, they would have definitely saved money on advising staff. They're already doing.
I was waiting for them to leave.
Yeah.
Over here. Oh, same problem.
You can just speak up.
So, Dr. Isa just talked about, hallucination, or Dr. Valorn likes to call it confabulation. And I had a question along those lines. I wanted to bring the topic of correctness into this discussion. All of you had mentioned that, students using ChatGPT, it's kind of similar to how, people were using calculators, and, that was not widely accepted. But a calculator is very different than ChatGPT, right? A calculator is a formal system. It's verified. With ChatGPT, you don't know whether what you're doing is right or not. There's a fundamental question of whether this is really right. And how does that factor in when you think about how you're going to adapt to generative AI in education?
Well, I guess so far have just been telling students that if you use ChatGPT, you better make sure that you have fact-checked it, that it's right, because I will. And so, feel free to use whatever tools you find are available to you, but it is your responsibility to make sure that the content is right, and there will be consequences if it's not.
Yeah, I've done the same. My current policy is you can use it, but you absolutely have to document it, and you're responsible for the correctness. And I think that's a big concern, kind of like Dr. Rashid was saying about when the public uses it. I'm part of a K-12 social media group, and they're scary with their faith in it. People ask questions, they're like, have you asked ChatGPT? And why do you think it will give you a good answer? There's no reason to think that. And I think that's a huge issue that I think probably the tech community has to do better at communicating what confabulation or I like that, because it's not a problem like a hallucination, right? Is where something is going wrong. I like confabulation because that's just how it works. But I think that that's a big issue, is I think too few people are suspicious enough of the answers it gives. And if you're using it for ideas, that's not a problem. If you're using it to create something, that's a problem. I don't know.
Yeah, I think a colleague in the math department once told me that ChatGPT fails miserably with their questions, with their types of questions. And I think someone, maybe Shannon, told me, if you give it a sequence of numbers and ask which one is the prime number, most probably it will give you a wrong answer.
Yeah.
I also did that like with some of my homework questions. So I decided to try ChatGPT. And I remember the question. It's about 1 nearest neighbor versus k nearest neighbor. Give one advantage for this over that. And the next question is give one advantage for the other over the first. It gave me a perfect answer for one of them, either the first or the second, and a 100% wrong answer for because it answered the same thing basically. So the order of the tokens in the sentence or something deceived it, and it gave me the answer to the wrong question, basically. So I think there is a lot of hype, and people think it's the answer to every problem. I think we would look back at this like 20 years in the future and say, oh my God, how people believe in these crude models that are no longer being used or something like that.
All right, we've got time for one more question over here.
Okay, so my question is related to what just Dr. Rashid said about using math, using ChatGPT and math, but especially in, let's say, computer science. So, for example, the coding assignments. We know that, for example, for essays or when you grab some information from ChatGPT, you can, I guess, you can use some tools such as Turnitin to estimate how much AI was used in that. So my question is, what do you think about the usage of AI in the programming domain or the computer science domain? I'm not sure if there is actually some tool that could help, like estimating the usage of AI and, for example, an assignment, coding assignment. Also, do we need to stay in the same domain of giving assignments to students, since some of them are able to just grab some solution online? It's not necessary to be on ChatGPT, but could be on some website online. So do you think that we could be thinking about different way of giving assignments in the domain of computer science?
Everybody's looking at everybody.
So I'm not sure that this answers your question, but something that I've been thinking about, and in particular because of sort of the capacity of more generative technologies, is what does it mean to focus on things like debugging and refactoring as part of a computer science education? It's a skill that I think is probably established in an undergraduate curriculum, is incredibly important in any workplace programming environment. And once again, it's a good application of critical thinking skills. And so even if you were to, let's say, generate a program, the capacity to then come back and tell me why it's good and why it's bad and how you would fix it or improve it or where there's optimization opportunities is, I think, another way to think about utilizing these technologies to then focus on what are the really important learning goals and how do we support students in those sort of in that end process. And I would hope that that would on some level be motivating of like, this is the type of stuff you do at work. You're going to be dealing with other people's programs and they're going to suck sometimes. How can you assess them and make them better? So that's maybe a sort of answer.
Thank you.
I just want to give a quick, things like Turnitin, any of the AI detectors have a very high false positive rate. And in particular, they're more likely to be false positive on a non-native English speaker. So for non-native English speakers, they're more likely to say that it is AI generated even when it isn't. So I want to, yeah, I mean, I would only use it if I already had other reasons to suspect, and I would never let it be the sole reason for my assessment of inappropriate use or something like that. And I think that's not getting out enough either, is that they're really not reliable in general.
By false positive, I guess you're saying it would say that this is AI generated.
Correct.
When in fact it's legitimately written by a person.
Correct. Yes, so like if you put in some of your papers from 10 years ago, there's a chance it'll say that they're
AI generated.
AI generated. And I've seen a lot of philosophers do this too, because philosophy tends to use big words and tends to be not something that was scraped off the internet in the training data. So lots of people, when it first came out, were just putting their own papers from like 20 years ago in and getting that it was a high percentage AI.
But it is going to get better. And I mean, so given everybody an example that, when Wikipedia came out, it had a lot of great information about coding because it was a community of coders writing things on it. And then eventually other people got onto it and it started bringing some more valuable information. It bifurcated medical information, WebMD and all that kind of stuff. So as long as there is an ecosystem that supports it, now sometimes that ecosystem is a bad one. I mean, so there will be a newer version of Check that's going to be even worse than Check. I mean, there is always going to be this arms race, but either things are going to continue to get worse or continue to get better because that's partly what the economics of the ecosystem supports. So, I mean, bottom line is, I mean, this is not supposed to, and I'm still an optimist, cautious optimist. I think it comes down to is that how we kind of start using it. I get constantly people come in and telling me that ChatGPT did something wrong. Did you actually read the EULA when you clicked yes on it? It basically told you it's an experimental system that will make mistakes most of the time, and you're supposed to be working with it. I mean, and of course, there's no replacement for being smart. I mean, I had things submitted with, when you cut and paste from the ChatGPT window, it also puts a line at the bottom saying this is from ChatGPT. I mean, at least delete that, for God's sake. I mean, be smart about how you use technology. And there's no replacement for that. So again, the bottom line is, while there might be a lot of resources, we got to still remain smart about how we use those technologies and what we do with them.
I think ending on a note of cautious optimism will be good. So could everyone please thank our panelists? I'm not sure what comes next. I think it's the poster session. Well, yeah, I'll do that in a minute, but and for everybody else, yeah.
Thank you very much. Maybe it's just an undergraduate grad difference. Yes. Thank you very much.
And again, in terms of nobody is
It's kind of the same in insight.
Yeah, just
Shiny badge.
Like
to even find out about it.
I like
that. Yeah, we worked so hard and thank you very much. I'm so honored. I hope I lived up to you,
Nothing better than swag.
So I guess I am the last person standing between the poster session and you. So I'll keep my remarks short. It's a short word of thanks. It's my great pleasure to offer our gratitude to so many people who have made this event a grand success. First and foremost, a big thank you to Dr. Irfan Issa, who has taken time off his very busy schedule. He has several papers, I guess, due today night, to be here with us and deliver the keynote talk on a very exciting research topic. Our sincere thanks to Associate Vice President for Research, Dr. Shelley Hooks, the Dean of the Franklin College of Arts and Sciences, Dean Anna Stanport, and the Dean of College of Engineering, Dean Don Leo, for being here and giving the welcome remarks. I would also like to thank all of the panelists for their wonderful and thought-provoking panel discussion. This event would not have materialized so well, but for the meticulous planning and execution by the Research Day Committee led by Dr. Buddha Karpinar, and the unwavering support from the school director, Dr. Gagan Agarwal. So thank you all. I also thank the staff members of the School of Computing, Nathan Shaman in particular, as well as all the student volunteers who have put in many hours of hard work towards making this event a memorable one. Thanks are also due to our MCs, Kriti Ghosh and Shravya Kodur, and the students who will be presenting their posters outside just shortly. Let's give all of them, all of our faculty, staff, students who were involved in this Research Day efforts, a big round of applause. Last but not the least, I would also thank all of you for attending this event. So the event is not yet done. We have the poster session outside, accompanied by a light dinner. We hope you enjoy the food and, more importantly, the posters that our students have prepared. Thank you.
So, please don't forget your, oh, yeah, sorry. And your jacket. So, that's it. Yeah, I mean, if you want to add how to do these applications, I mean, I don't know if you want to, maybe 5 minutes, you can walk around the posters, some of the posters. But if you want to maybe bring the car and take in, so you know where you're going to. Yeah, and maybe that will get you there, and I will walk in. So, I mean, maybe I can, what I can do is.
Stop. Close it.